I see what I, yeah. Good afternoon. My name is Malte Bayer-Katzenberger from the European Commission. I'm part of the team inside the Commission, more precisely DG Connect, that has been setting up this conference series for a number of years now. Great pleasure to see so many of you here in the room and at the conference. It's an exciting preparation time, and when you see it then at the real thing, it's really rewarding in terms of the turnout. The session that we're going to propose to you this afternoon is on data-driven government. No one should think after the session that inside government you can't get data-driven. And we'll see a couple of different examples that are in different levels. We'll start off with the first presentation on performance indicator-based policymaking, and I'll say maybe a few more words about this in a second. Then we'll have a second presentation that tries to present you the efforts made by statistical offices. So very traditional data providers at very high methodological standards, how they embark on a big data journey and how they try to make it useful for them. Then we go over to a presentation where say how can actually innovation around digital and data happen in government, and how can it bridge frictions between the citizen and the administration, how can that function, or the companies. And the final presentation is how do we provide better services to citizens in a privacy mindful basis. Maybe from my side, I mean, the unit we're working in has been started off doing two basic things. Was open data, so we have the famous PSI directive in our remit, which kind of obliges government to open up their information. We also have been launching at the past EDF a commission-funded initiative on the Pan-European Open Data Portal. There's a stand upstairs, which is basically harvesting openly available data from government data portals from all over Europe. We also have a strong background in financing, well, activities around research and development around data, the semantic web in the past, now really big data analytics. And we're driving this now forward to data-driven everything. I want maybe to share two additional info points before handing over to the first speaker. The Commission also tries to be more data-driven, and we've been experimenting a lot inside services. What type of data do Commission services have? What capabilities do we have in terms of people and technology inside the Commission to make more of this? And it's true that we're a bit at the beginning, but not quite. So there's even small in-house applications to be developed. So when we do our famous public online consultations, now we can really map the results. We have them automatically translated between all the languages of the EU. And that is really useful tools that we use also to manage the sheer inflow of information, which is not only about numerical data, but also sometimes about very textual information. Finally, I want to point you, if you want to do some background read-up, on the e-government action plan, which a different part of DG Connect has published just a couple of weeks ago. And this e-government action plan for 2016 and onwards tries to do a number of things. It's trying to promote digital government throughout Europe. It tries to set the aim of digital by default. Sounds maybe a bit counterintuitive to some of you who have recently been to an administrative office in some of the countries, but digital by default should be the new rule. Transparent by default should be a rule, and there's a open by default, obviously, but there's also the idea that data management inside public administration should be such that citizens and companies, most importantly, don't need to overly provide information again and again about them, but that there's a mechanism inside the public sector that helps you to, that enables that information flows to the extent necessary and to the extent appropriate, looking at privacy and commercial confidentiality issues. That's what we call the once only principle, and that's one of the major strands I may want to highlight from this e-government action plan. Google it, read it up. It's a short read, and that should give you also an update what we try to not only do ourselves inside the organization, but we're also trying to promote with member state government, and there's a lot of work going on. Coming to the first speaker, it's Johann Höchtl from Krems, the Donau-Universität Krems. He will talk us a bit through the Austrian model of steering, policy making, and measuring impacts through performance indicators. He's been a distinguished researcher for a couple of years around open data and e-government with lots of advisory roles. And he'll give us the first presentation of this session. Great that you're here. Thanks very much, and thanks for the attention, and enjoy the session.
Thank you very much, Malte. Thank you very much, Malte, for the nice introduction. Wow, such many people are in here. I'm really overwhelmed that so many are interested in data-driven government. If you take a closer look at the program, you will see that there was actually a change, because I was supposed to speak last, now I'm speaking first. But we are all used to change. This is part of our life, part of the society we're in, but I'm not talking about change today. I'm more talking about speed, and the speed of our society got used to. Companies which push us to speed, and the government to a certain extent, which has to catch up to that speed. So this is going to be the topic. Now, we have heard during the keynote speeches, the wonderful keynote speeches during the morning, we have heard a lot of things where all the wealth of data is coming from. It's coming from the Internet of Things. It's coming from sensors. It's coming from our cell phone devices. There are more than 6 sensors on it. The last Android software development kit says there are 13 sensors. And if you happen to have a new smartphone, all those sensors might send data back to the originators. So we are really, really driven every single moment by information which is hammering at us. It is really speeding at us. Now we get used to that speed, but the question is the government actually up to that speed? And I would say government infrastructures, organization and also infrastructure, within, let's call it silos. Of course, the silos are breaking up slowly, but there's still silos in. We are still relying pretty much on infrastructure, which is from the 19th century. And this is really a challenge. Now, the question is, where is all this change coming from? We've heard it already, of course, it's digitization. We digitize pretty much anything today. We digitize ourselves, the genomes. We digitize books. Every picture we take is bits and pieces, bits and bytes transmitted. There is one aspect. The other thing is connected. All those sensors and Internet of Things, they are tied together. And the third aspect, which makes this virtuous triangle, is the intelligence. Not the intelligence, or not only the intelligence of people, it's also the intelligence of algorithms, of machine learning, of all the capabilities the data scientist, for example, should bring in. Now, when you put those forces together, applications become possible, like mobility, our cell phone devices. We are all always connected, always producing data. We are really used today to work mobile. Then we have cloud computing. Computer networks spread all over the world, which bring services to us, and they enlarge this landscape of services. And now we have big data analytics, which is happening largely on cloud computing infrastructure. They allow us to gain insights into these bits and pieces of information which is coming to us, and is really a precious information. We have heard that there might be only 1% of valuable information and 99% noise, but this 1% of information is important to capture and important to find that salt or that needle in the haystack. So that brings me to the point, we are extremely data-driven, information-driven today. I would even say that we are data-driven, we are even obsessed by data. This has not always been the case. Looking back only 19 years or so, the US, for example, has been in a big depression. In 1929, President Hoover came into force, and he was asked to get the United States out of this deep depression. And he called he called his economic scientists and asked them, how can we get out of this deep depression? And they all claimed, yeah, we have to take a look on how much railroads we produce, the miles of railroads, for example. Whereas others said, the tons of steel we produce each year, this has to increase. Others said the acres and morgens of lands which are available to produce crop are of importance. We have to increase that. So everyone he asked gave him a different aspect of how the economy should evolve. In 1932, a Russian immigrant, Simon Kuznets, conceived a new model of how this economic situation could be put into a number, and this number later became the GDP, which is a concept of its time, by the way. It's, yeah, we could argue if GDP is a good measure, yes or no. I would say no, but anyhow. But it was in 1920 when the National Bureau of Economic Research was founded. Of course, they had one employee, like Microsoft and all the other companies. Also started only with one employee. But only a couple of years later, in 1945, this government institution already had more than 5,000 employees. So that was the time when this data-driven government really took off. That was the day of birth, if you would like to say. Now, just to give you an idea how complex this GDP, be it a bad concept, yes or no, actually is, it consists of really a lot of subcategories and sub-numbers. And yeah, I have a laser pointer here on. For example, personal consumption, net exports, defense, commercial capital goods. Now, only if you think about that, if a government should release its official GDP numbers, how many departments the government has actually, how many ministries and federal agencies the government actually has to ask for detailed numbers just to come up with one single number. And ironically, we measure the performance of a country with just one number, whereas we're buying trousers with two numbers, width and length. So, but it's another topic. Even more, it's complicated to come up with that number, but unfortunately, these subcategories also have deep intricacies and dependencies amongst each other. So you can see there are feedback loops. If you change one aspect here, okay, it's fading now. If you change one aspect of, let's say, income, of course, you're changing consumption. But as consumption rises, goods become more expensive, which has effect on which has an effect on savings, for example. So it's really difficult to come up with a measure and say, if we tweak on that side, we will raise GDP. Now, action taking on evidence. If you want to come up with this GDP, this is just an illustrative example, you have a couple of input factors, you have a model, and what comes out is a number on which you can base decisions. And as we're talking about government, those decisions have, for a prolonged period of time, 40 years or so, been made according to the policy cycle. Policy cycle starts with an agenda, then you're discussing, then you settle on your policy formation. It will be accepted somewhere. Then you have to assign means to it, you implement the policy, and in the end, there is evaluation. But there is a downside to that. Namely, our society and our times have changed a lot. This input from the previous slide you saw today is just so many devices which can provide input. We have already been talking about the smartphones. There are RFID, for example, is an input. The Internet of Things is an input. Copernicus, those are the satellites now orbiting around Europe and sending immense amounts of data to the base stations. So we have the social networks we can listen to. What do the people actually want? Which policy shall get accepted? Now, there are many more input factors into those models leading to the decision, but actually also our decision models have changed. They got more and more complex. They are not that easy as they used to be. And they also provide feedback. There's a forced feedback mechanism. If you make a policy, make a decision, it has an influence on its input. So there are many more things to consider, and the question what arises now is, according to which model shall we model our decisions now in the future? Now this is all a bit conceptual work, so I think it's time to get down to earth, and I will present you what that means for Austria. A couple of years ago, the Austrian Chancellery was faced with the challenge that budgets were made in 2 years, for 2 years budgets. And after those 2 years, people were asking, why did we put that figure, or why did we assign that amount of money to Ministry XYZ? And some of those couldn't answer that question. We don't know why we assigned that money to that ministry. And it was also very much oriented on the input. So how much money do we give a province? How much money do we assign to a ministry and so on? But what is really important, or would be of much higher importance, is what do we actually want to achieve on societal effects, on the outcomes. So in 2013, the Federal Performance Management Office got established, FPMO. It's assigned to the Austrian Chancellery, and in order to give you an idea, the Austrian Chancellor, the Prime Minister of Austria, is not leading like it is in the UK. It's just one ministry next to the other, so it has a counseling role, but not really a strong leading position. So the question was how to manage the public administration based on its contributions to achieving outcomes in society. It's called performance management. And ministries were asked to provide outcome statements. What do they want to achieve in societal values? And what was also conceived was a performance management cycle. And they also had to provide measures how to assess the achievements after one period, if they were actually successful in what they claimed to be able to implement. Now what has really changed is, and I think this is a really good overview on how this performance management in Austria is planned at stage 1, the planning stage, is what the politics describe what objectives shall be achieved. And what the ministries should come up with are outcome statements at the very end. And these outcome statements are really targeting the effectiveness aspect of the whole thing. Doing the right things. Whereas in between, the public administration shall carry out those outcomes by services, measures they take. Those measures require inputs, and the inputs to those measures, to those activities, provide an output. And here, of course, we reach the aspect of efficiency. It doesn't make sense to waste money there. But what is important is, in order to achieve an effect, sometimes it makes sense to sacrifice the budget of one ministry in favor of another one. And this is called global budgeting. It's a measure to prevent achieving local optima, but with a global budget, it's more easy to achieve a global optimum. Now, how is this carried out in Austria? We have a varying number of ministries. It really depends on the outcome of elections and so. But what is fixed is there are 30 through 32 budget chapters. Those budget chapters, they are assigned to one or more but one ministry. At least one budget chapter is assigned to a ministry, but a ministry can have more but one. Those have to come up and define global budgets. And those global budgets are then furthermore detailed. Think of global budget as a budget for society, a budget for transport, a budget for defense, for example. And the detailed budget would mean in the like budget for police, for example. Those are detailed budgets. And those budget statements, the ministries are also asked, now explain why you want to have that amount of money and also explain what mission you want to achieve. Tell us your strategy and tell us what should be the outcome at the very end. And to further detail that, in order to achieve that outcome, certain services have to be provided which provide an output. So on the global level, on the global budget level, output statements have to be provided by the ministries. And what is really interesting, what is really important now, they also have to provide the indicators how this outcome, this at the very end, the outcome, could actually be measured. Because this is a very important aspect, this formal performance contracts at the end. Now, how does this look like? Just an illustrative example. Explain why this outcome, safety and security in public and private life, is a human right and essential to well-being and so on and so forth. What is being done to achieve this outcome? So the measures they plan to do. And for each of those measures, and this is the most important aspect to it, how will success look like? How do you plan actually to measure if what you plan to do will be successful, yes or no? And here do we have those performance indicators. Those are actually measurable values. And in a second phase, after one period, after this policy has been carried out, so after implementing period, what comes next is the evaluation to it. Now, this is phase 2. It's monitoring and controlling. If after those statements have been made by the ministries, in the next period, what happens is controlling if they have been actually successful in what they were claiming to do. Now, this is actually taken from a slide from the FPMO office, but if you remember the policy cycle we had I showed you in the beginning, this is very, very close to the traditional policy cycle. You start with a strategy, you assign performance mandates, you implement it, you evaluate the output and the outcome. The evaluation is at the very end. And how this evaluation is also the evaluation, the performance management office asks the ministries, now give us the numbers so we can fill in the case of Austria, it's a website available as wirkungsmonitoring.gv.at, where they present to the public, to the ministries themselves, to the parliament, how good those measures have been actually, in how efficient they were implemented and how effective the outcomes have been. So this is all a platform. It's quite accessible. You can click on it. You can you can drill down into from very large-scale mission statements down to concrete measures. But of course, there is a downside to that. Okay, this is also going to be presented to, first the ministries will report to the performance management office. The performance management office will give feedback, and then it will be presented to the parliament. In order to be effective, it's also written in law. So this principle of performance management in Austria is, for example, even in the Federal Constitution Act, it's more concretized on Act on Federal Budgeting and Ministry of Finance, for example, and the Austrian Chancellor will even further detail it. So it's really, ministries are forced to do it. But there is a downside to that. The downside is lack of integration. The ministries are asked to give the numbers, to provide the numbers back. It's not the Austrian Chancellor which can query the back-end systems, but the servants really there have to provide those numbers. and those reports arrive really, really late. Now, I'm not going to tell you about big data because all you know about big data. But really the point at the very end is what is missing here is velocity. The speed. There are sensors and social networks. We have been talking about stream orientation and real-time processing, but none of that is happening. There is no stream orientation and no real-time processing. So now the question is, the policy model of e-governance 2.0, how shall it look like? This was the traditional one. The traditional one is discussion happens in period n-1, implementation in period n, and evaluation in the next period. But it really lacks all of those sensor networks and input to this data which is available is not considered in this policy model. And a lot of time is missing to refocus on measures or even drop measures altogether where it would already be obvious that a measure doesn't make sense. So the traditional policy cycle, as we know it, is simply not apt for policy making in the 21st century. That's why we brought up a new, revised policy model. And if you take a closer look at it, it's all the same like the previous one, but what is missing is evaluation. There is no evaluation step to that. And the reason is, with big data, with stream processing, with real-time analytics, and with integration of back-end systems, what we can do is to evaluate constantly, all the time. If, of course, this would require that lots of back-end systems would have to change. The efficiency gain, for what we gain is, what would be required is that we have to integrate the back-end systems. If it would be much more efficient as we could react much faster to changes, to reassess the policies we decided to, or the government has decided to make. And it will be also more effective because we can identify patterns in the data sets if we integrate those back-end systems. And how to go to that, how to achieve that, and this will be also topics of the next presentations, is integrate back-end systems, operate on cloud infrastructure, on higher level infrastructure than we do today, allow systems to evolve, not disruptively change it, but evolve it. But this evolvement also requires to know what the user actually wants. So listen to your stakeholders and monitor the use and design those services using a co-creation approach. This is what next presentations will be about. And as I have to leave, maybe there is time for questions. Please submit your papers to CEDAM 17 conference, which will be in Krems next year. Thank you very much. There is room for one question, I've heard.
Can we see the evaluation cycle slide again?
The evaluation cycle. The original one or the revised one? The new one. This is the one without evaluation. This is one with evaluation.
I'm testing my skills here. You just want to take a photo, is that why you're asking the slide?
Yeah, that's why I said I'd give my question to somebody else.
I see a question there in the middle. I'll throw out these, I run.
Thank you. Kim Smarter from SMR, which is the Association for Market, Social and Opinion Research. My question is regarding to what extent, so one of the issues which we have with policy making is that we identify a challenge. It takes us 5 years to research to identify what the solution might be. And in between, actually, you have citizens who are becoming frustrated because government isn't reacting. So my question is, to what extent can we actually use data to accelerate that process? Is there a way for us to enable, for example, all of us have ideas and we can directly now relate to the government. So can that actually influence the way we actually make policy itself?
Certainly it can. The integration of social media, for example, comes to mind, but this is some sort of knee-jerk reaction. We have this since a couple of years. E-participation is the answer, but what we see is that participation only happens at certain stages of this policy cycle, for example. Most of the time, participation is only provided in the discussion phase. But if you think about it more closely, participation can even happen in provision of means. When you think about co-creation, for example. co-creation is not that widespread happening in government. But when you think about design of services, and if government services are more open and provided, for example, through application programming interfaces, APIs, others can conceive solutions which the government don't necessarily have to provide. So there are many more levels and many more contact points to participation, but mere discussion. So I think this is the answer: how to participate in each and every of these phases, and not only in the discussion phase.
Great, thank you very much, Johann.
Thank you.
This is the ideal conceptual framework for the next discussion. We do a little swap of microphones and also change the slides while I'm introducing the two distinguished speakers. As announced, we'll now look at the refinements that can be done to official statistics, which are probably the basis of some of these things as they happen. Please come on stage as you have your microphones already, and we'll see the new slides. I'm announcing two speakers. One is a colleague from, as I can say, just down the road. It's Albrecht Wirthmann from Eurostat. He's in the Big Data Task Force, if I can announce already that there's a Big Data Task Force inside statistical organizations. And as you know, that Eurostat is not aloof, but it's part of what they call the European Statistical System. So the collaboration of all the national statistical offices, of which CBS, the Dutch Statistical Office, is today the representative, with Barteld Braaksma, who is responsible for the innovation program and the innovation lab at CBS. And together, they are having signed the Scheveningen Memorandum a couple of years ago, which they will present to you, which provides the conceptual and governance basis for experimentation, if I can say, with new methodologies on improving the speedy delivery of statistics. I think some of the things that we have seen in the previous slides that this will respond to. So I'm really looking forward. There's a number of very interesting pilot projects that I can announce to you, and looking forward to the next two speakers.
Thank you, Malte. Okay. Okay. So, as already introduced, my name is Albrecht Wirthmann. I'm working at Eurostat in a task force which was created in 2014 as a reaction on the Scheveningen Memorandum. We are working together with national statistical offices in exploring big data sources, also for purpose of official statistics. And in this aspect, my colleague Barteld Braaksma from the Dutch statistical offices, we are doing this presentation together. We are also working together in different groups exploring these data. I would like to start with some quotes. So already in 1942, William Edward Deming said that data is there for doing something, so having as a basis for decisions or for actions. This was long before big data, the term big data was coined. There at this time you had really to do an effort to collect data, and you thought well before collecting the data for what purpose you would use the data. Now the things have changed. So we living in a data deluge, data is coming more or less automatically, but then still we need statisticians. So I think we had also the big data is at the heart of statisticians, because you need statisticians to put meaning into the data to analyze, to be able to analyze the data. I think it's clear that data has become more and more an infrastructure, like the transport network, on which basis you can improve the economy, but also do goods for the society. Just the purpose for which we are working within the European statistical system. So we want to provide high quality information. We want to be independent, independent especially from policy. We want to provide independent information to the society. and in principle to everybody. So also the results of the statistics in principle is free of access to everybody. And we are living, or we are working in an ethical environment which is called European Statistics Code of Practice, which has also some consequences afterwards on our work with big data. What are we trying to achieve with big data? So we are hoping that we can provide new statistical information using these new big data sources, but we are also trying to improve the current statistics, in terms of timeliness, to provide faster data, also to provide some early indicators for certain things, for more statistics than we do now. And this is always to the pleasure of our bosses, to increase the efficiency in which we are working, so to become cheaper, to produce the same or more statistics with lower costs, but also to reduce the burden on respondents. So instead of asking people, then we rather take a look on and analyze big data sources instead of burdening them with questionnaires. Everything started in 2013. There, the Director Generals of the statistical offices came together, and there was a declaration, a so-called Scheveningen Memorandum, adopted that was the basis for a joint action of the statistical system to explore these big data sources. In the subsequent years, we did some action plans, and the European projects in principle started in 2015 with some pilot projects. There we also, at the same time, we started partnerships with stakeholders, so there are also initiatives within the European Commission. Partnerships with academics, because we are lacking skills in principle at statistical offices. And with businesses, most of the data are held by private businesses, but also listening to the demands of the users. We have a number of pilot projects at European level. These pilot projects focus on certain data sources. So in principle, they are always a number of statistical offices working together, analyzing certain data sources, and the results of these analysis should feed back into using those data sources for creating improved or new statistics at the European level. So some offices are developing something that could be applied in general. We are facing on certain data sources, but we are also studying the issue of putting data together, and also concentrating on cross-cutting issues like what is the legal situation for accessing the data, for using this data, can statistical offices easily access the data, what are the ethical implications of this data according to the code of practice, and what are the necessary skills for using this data. In the following, I will show you some concrete, or we will show you some concrete examples. This is about mobile phone analysis in the Netherlands and in Belgium. This is what we are doing together. Analysis of smart meters, electricity smart meters for statistical purposes. Some analysis of traffic loop data for traffic statistics of social media for different applications. Okay. So this shows a picture on the left side. There is the population according to the census in Belgium that was made in 2011. So you see the population distribution in Belgium. You see the big cities. And on the right side, there is the same, there's the distribution of mobile phones in Belgium. You see that the distribution is quite similar. So we are working currently together on a project with one Belgian mobile phone operator and Statistics Belgium on exploring these data sources for resident population. And we hope that we can provide this information in a higher frequency and also to reduce costs for data collections. The resident population, normally we call nighttime population, so where the people are spending their nights. This is the same graph based on mobile phone data showing the nighttime population. And we also want to go into a new area which has not been collected yet. This is the daytime population, so that we are able to show the different population densities during the day or during typical days. The second example is the analysis of smart meters. There we are doing a project with 4 European countries together, where there already are smart meters rolled out. This is an example of a first results of Estonia. On the left side, you see the electricity consumption in January. And on the right side, you see the electricity consumption in July. And this is a typical daily consumption. And it's with a higher geographical granularity that has been possible so far. The hope is as well that we can get this information at faster intervals and also at instead of have yearly information or monthly information, for example. Then now I give over to my colleague from Statistics Netherlands, Barteld Braaksma. He will explain you some more examples in the Netherlands. Thank you.
Okay, I hope my microphone works. Does it work? Okay. So what I will try to explain very briefly is a few examples that we studied in the Netherlands. So the first is related to traffic loop data. So these are sensors that are built into roads. You see an example on the top right. Altogether, we have tens of thousands of these traffic loops in Dutch high roads, and most in the major roads. And important here is to mention that this is not privacy-sensitive information. No number plates are recorded, just that the car or truck is passing. And first thing that we did was just aggregate all of them and look for a typical the typical weekday, a Tuesday in May 2012, if I'm correct, and see what comes out of it. So what you see in black is the pattern for personal cars, for small cars. You see the morning rush hour, something between 7 and 8 o'clock, evening rush hour at 5, 6 o'clock in the afternoon. In between, those cars leave the roads. So that's the expected behavior. When you look at the large vehicles in green, the trucks and vans, you see somewhat different behavior. At night, there's a little bit more on the road. So these are normalized pictures, so it doesn't mean that there's as much trucks as personal cars, but relatively speaking. The morning rush hour is a bit earlier for trucks. And the strange thing is that when personal cars have the rush hour, trucks get off the road. And during the day, they are on the road and you don't see a clear evening rush hour. So this was quite unexpected. Everybody we show this picture has some explanation for it, so I challenge you to find your own explanation for it. I won't give it now because I don't know it. It's just something that came out of the data. And in red you have the medium-sized cars. So in blue, those are all the locations for the traffic loops in the Netherlands. So all these 60,000 of locations. So this was just playing around to get to know the data. Then we said, well, we can try to base statistics on this. We managed to do this about a year ago. So we now have a formal traffic intensity indicator, which is entirely based on this big data source. That's a first for us, and also first worldwide, I think, to be able to produce official statistics based on this one source. It took us half a year longer than anticipated to release this, because we're very much quality driven. And all the time our people in our traffic statistics department asked us, hey, what's happening here? I see a strange phenomenon there, and so on. One of them was that at I think September, the day a couple of years ago, a road between The Hague and Schiphol was completely empty. It was normally quite busy. Then we checked that. We found out that was the day that President Obama was visiting the security the summit in The Hague, and CIA had asked us to switch off all these traffic loops. So you see that you find all these incidents. We have to learn how to deal with this, for what's really happening there, and the detail in it is much higher than what we're used to. Another thing that we can do now is to become much more timely with statistics. First 3 working days of this year, 2016, in the North Province of the Netherlands, there was an issue with freezing rain. So the rain that came down froze immediately on the road, so it became very slippery, almost impossible to drive. Economic life, social life came to a standstill. We were able to, this was during Monday, Tuesday, Wednesday. On Friday, we were able to release a press statement saying what was the effect. You see that here on the right. In light blue is the normal behavior, the normal traffic intensity average over 3 years. In dark blue, you see that the traffic intensity over these 3 days. So it's basically on the larger roads on top is half of normal. On the smaller road, the provincial roads, is 1/4 of normal. So this is very different from what we did in the past. Remember the previous presentation by President Hoover had to wait 3 years for the numbers. Here you have to wait for 3 days. So that's quite amazing that we can do this. Oh, I thought there was a slide in between, but that's apparently gone. So this is the second example, which is about use of social media. There's another source that we can get access to. It's actually we get that from an Eindhoven-based company, which is called Cousteau. They collect all social media in the Netherlands. So not only the large ones like Twitter, Facebook, and so on, but also smaller blogs and whatever. So they have a very complete coverage of all public social media in the Netherlands. So we got access to that data. And first thing that we try to do is, well, can we connect everything on social media to our statistical themes? So what you see here is the themes that we distinguish in our statistical publications. So one extra, which is media. We thought, well, people are talking about that. It's in the middle, you see it. And what you see here, also this is very explorative. So you expect people to talk about spare time. But what people talk most about is this other category. It's about half of it, which you can also describe as pointless babble. We could not make any sense of it, so maybe we aren't smart enough, but basically think these are messages about nothing. But still you have an amazing amount of messages. The millions of social media, the messages appearing each day anew. And they also have a backlog for a couple of years. So then we use that information to calculate the kind of sentiment indicator, because they also attach a sentiment score whenever possible to each social media message. It's possible in about 1/3 of the cases, so you lose 2/3, but still 1/3 of a huge amount is still a huge amount. They look for words like good and positive and whatever to attach positive sentiments, sad, and words like that to attach negative sentiments. Also look at emoticons. And what we do here is very simple. We count the messages that have a positive sentiment attached to them, abstract the messages that have a negative sentiment attached to them, and then normalize. What you see here in the green is the daily scores, which are quite chaotic, moving all the way, but we also didn't try to smooth it or whatever. In red, you see the weekly the aggregates, and in black, you see the monthly aggregates. So that already looks very much like a useful statistics, you could say. On the inside, you see our traditional consumer confidence statistics, where you ask each month to 1,000 people, randomly selected in the Netherlands, the questions about the economy. Very simple questions. Do you think the economy is in good shape? Do you think this is time to buy expensive things? We count how many people say, well, it's okay. Do we subtract how many people say it's not okay? Normalize it, and that's this indicator. And what you see here is an amazing coincidence between what you get from traditional statistics and this big data source. Still, we have not decided to release this as an official statistic because there's too many questions that we have. You can, for example, manipulate the social media. You can also try Another risk is that the behavior of people on social media is changing over time. For example, a couple of years ago, Hives was the dominant social media in the Netherlands. It's now completely disappeared. So if we had to base an official statistics on that, we would be lost. So continuity of data is very important to us, as is quality and reliability and so on. And the third example that I'll show very briefly, because Albrecht already showed mobile phone data in the use in Belgium. The situation is here more or less the same, only we work with Vodafone and an intermediate company, Mesuro. So actually Vodafone sends their information, called detail records, is the technical name for that, on all kinds of phone calls, SMS messages, internet use of their customers to Mesuro in an anonymized way to protect privacy. We specify queries to Mesuro and then we get the query results. Also with some safeguards to protect privacy of the individual the customers of Vodafone. So that's the base of what we do. Then we do all kinds of statistical manipulations. And one of the things that we came up is this picture of behavior of people during a typical weekday. So, I think it's a Tuesday again in May 2013. And what you see here is in blue the areas that are less densely populated than you would expect according to the population register. In red, areas that are more densely populated compared to population register. And what you see here is that in the large urban areas where all people work, central areas like Amsterdam, also Eindhoven more to the south, Groningen to the north, they become red during the day. So that shows that people are moving there. The areas around them where the people live and commute to the centers, they become blue. So that means that people are leaving from there. So this is something that's quite new. You can do this in a very timely fashion. But also here we have not released this as an official statistic. And the reason is that we are not completely confident that the quality is sufficient. So we can make these pictures, they look nice of course, and we also have the feeling that it means something. But when you start to use this for policy purposes, you want to be quite sure that you don't make any mistakes. For example, at municipality level, there's a way to distribute budget from the central government to municipalities based on the people that live in the municipality and some other criteria. You could also try to include as a criterion the people that are actually there during the day. But then you can imagine that there should be no debate about these figures themselves, because this is about huge amounts of money. So we must be very sure about this. Another question is what level of detail would you want here? We talk with people from the municipality of The Hague, where CBS is based in the West. And we asked them, we have figures for The Hague, and say, that's nice, but we want figures about a more detailed level. For example, in summer, which people are going to the beach at Scheveningen during daytime, and then at nighttime go to the center of the city to have dinner there. So they want more detailed information. So that's what we try to discuss with them, and also what way to present and so on. And also we interact with them when they think it's useful for their policy purposes. So this is in a bird's eye view of the kind of results that we now have. Most of them are pilots, apart from this traffic loop example. Then what you see is, I mentioned briefly a number of issues, but here I enumerate them. First and foremost, an issue is access to data. In traditional statistics, we can send out a survey, we design it ourselves, we have control of the sample that we want to include in the survey, and we process it by ourselves. So basically, we don't need nobody for that, apart from the respondents. In this case, we need to work with those parties who have access to the data, and they have to be willing to share it with us, which can be quite difficult due to privacy confidential issues, reputation risks. For example, for phone companies, they're commercial companies. If they're in the news in a bad way, then they're lost commercially, so we have to take care of that. We have to take care of interpretation of data. The previous picture was about where phones are, so then you have to make a translation to where people are, because that's what we're interested in. Stability and continuity. I already talked about social media that are not so stable and disappearing and changing all the time. Methodology in IT. Some people say big data is about IT. From our perspective, that's a problem, but it's a minor problem compared to some others. And what's already mentioned, knowledge and skills. So we need new people, data scientists, and also people that have abilities to look at data in a different way. So that's some issues that we encounter now. And one way to deal with that is by cooperation. So we cooperate, as Albrecht already has mentioned in his part, with a lot of different actors in the international community. With the project that Albrecht explained, with international organizations, they are very much interested in big data, for example, for sustainable development goals purposes, which is very important political agenda. We work with universities and also with commercial partners who have niche knowledge or have data or whatever. So basically we cannot do it alone, and we don't do it alone. And this is an example of a collaboration which we have with the university, Twente University. And last year in November we organized a one-week data camp, which is a kind of hackathon focusing on big data. And what we did there is bring together 10 people from our office who have a lot of statistical background knowledge but didn't know anything about big data. We matched them with big data specialists of Twente University, juniors there, PhDs, and so on, who didn't know about statistics, brought them together and say, well, start to work on these data sources and see what you come up with. And those are two of the examples of the results that they got within 1 week. On the left, you see the arrival of spring in the Netherlands based on indicator flower. You can look at how many times it's mentioned on Twitter, this flower, bosanemone in Dutch. And then you see different patterns in different years. 1 year is going from west to east in 2014. In 2030 it's going from north to south, basically, and also with a time shift due to the weather conditions. So that's one example. The second example is about the relation between traffic intensity and GDP, which is also quite interesting, because you can imagine if there's more traffic, there's more economic activity. And what these persons proved here is that there's indeed a very strong correlation. So we try to investigate this further, because it's only very first results. And it's not really an official statistic yet, but it looks promising. And also the interaction with these people from Twente is very useful for us. So to wrap up, the main message is that we are very actively working in big data in the official statistics community. We started a couple of years ago, so we are only just starting. We only touched upon it in some pilots. You also see that across Europe, other statistical offices are also catching up now in the European context, which is quite good. So we are working on partnerships. So if people here in the room are willing to work with us, you're very welcome. We're willing to talk with you. We look for new insights. So what I just showed you are some new insights that you can get from the data, in addition to enhancing existing insights. And also try to find additional applications. And what we're very much aware of is the quality of our data. So we're very quality driven. Our data is used for policy goals, and it has to be good, or otherwise we will not do it. So, and my final slide is it's about a quote, an interview with Helverian from Google. It was already mentioned this morning. The sexy job for the next 10 years is statistics. This quote which is very popular in the statistics community, as you can imagine. Is from 2009, so we have still some more years to go. But apart from that quote, what he's really saying is much more important. Data is not a problem, he says in this second part. It's about the analytical skills, which was also mentioned this morning. So we need to be able to understand it. I think statisticians are part of it. We think so too, of course. But what he also says is very important, that people, managers especially, but also policymakers and so on, they need to be able to analyze their own data. Just like nowadays you don't go to a secretary to have her typeset a document, but you write your own emails. You don't go to a librarian to ask, find this information for me. You go to Google and type in the keywords and work from there. I think with data we're also going that way, and how it works we'll have to see. But I think there's some big changes ahead. Okay, so also on behalf of Albrecht, thank you very much for your attention.
Thank you very much to both of you. I think we can make maybe a short poll in the room. Who would have expected this from statistical offices? Some claim they did.
Some no.
Some knew, obviously. One or two we'll collect 2 questions and leave it to you to answer. I'll have a helping hand here with the throwing.
Hang on, I got it.
Hi, Peter Campbell from the European Data Innovation Hub in Brussels. A question for both of you. I've been doing some lectures on big data at the universities in Belgium, and I have a lot of sections about open source software, which is, as I say, is coming fast and furious. I remember 20, 30 years ago, we had SPSS and SAS, which are still around. Mm-hmm. SPSS being part of IBM now. And then now we have things like the R language. In databases, some people are moving from Oracle to, let's say, Postgres. I would just like to hear some comments on what you're seeing with open source tools and in your organizations.
I'll take the two questions. Yeah. Is there a second question? Not a bit behind schedule, as always in a good conference. Interesting speakers. If that's not the case, then we'll.
Yeah, I can try to start that question, and maybe Albrecht can add. What you see is that open source is becoming much more important now also in the statistical community. So at least the examples that I showed from the Netherlands, most of programming work is done in languages like R and Python and the like. So we rely a lot on these open source tools. We are also setting up our own Hadoop and Spark environment, which is also based on the same open source tools. And you also see in the international statistical community that this is catching up. So a couple of years ago in Ireland, we set up what we call a sandbox, a statistical sandbox, which is an IT environment for people connected to a United Nations community in statistics that can use that to freely experiment. And it's also very much based on open source tools. Of course, that's not the only thing, because also the big guys, the IBMs, Microsoft, Oracles, and so on, they're also very active in the field of big data. So for us, it's something that we always try to find a good balance. So where do we use these tools provided by the big players, and where do we use R and other open source tools? But I think these open source tools they're become much more important than they were in the past, especially if you want to work with academic parties, because that's a standard.
Well, I can only echo what Barteld is just saying. So I think the importance, as also at Eurostat, for open source software tools is increasing, especially in our group on working on big data. So a lot of analysis is made with open source software. We are also using or supporting this infrastructure in Ireland and putting data there to be used for experimentation within the whole European statistical system, which is mainly based on open source software. And we are also taking some actions internally at Eurostat to think, because in principle, production systems now is based, we are using mainly as SAS, for example. But now we are thinking of also how to integrate, for example, R into that, and how a government structure or management for R could also be used within Eurostat. So it's gaining in importance, especially, well, also working or having activities in this area, and also working together with the scientific community.
Okay, thank you. There's a man hiding behind the pulpit, but he's our next speaker. It's Matti Schneider, joining us from Paris, from the central government of, from the Modernization Secretariat, if the two words can go together, at the French Prime Minister's office. He's a strange animal. We had a longer chat last night. He's a startup inside government. Yeah. How can that work, Matti?
Well, thank you, Marta, for the introduction. I didn't have time to open that bottle. I think we'll be fine. So don't worry, even though it's written in French right now, this presentation will be in English. Though to compensate, of course, I will have to start with the huge French flag. So we are I represent the French Digital Services Incubator. We work in the heart of the French state in the interministerial direction of digital. It's actually slightly longer in French, but I'm giving you the shorter, to-the-point version. Our aim is to spread the culture of digital innovation throughout the administration, and we do this through an experimental process called the state startups. So what's state startups beyond being an oxymoron? It's very simple. It's a match between a team and a mission. So there's no capital investment, there's no separate judicial entity, there's none of that, even though there's a startup in it. It's a way to create a team that will have the same kind of constraints as it would encounter in a startup, to unleash the power of digital innovation that is usually seen in startups. So we take very small teams and we task them with solving one specific friction between the administration and citizens or any other stakeholder. And they have to publish a digital online service within 6 months, available to the public, and for an investment that's limited to 200,000 euros, which is just paying the salaries of the people working there, of that team. So the very first state startup was the new French open data portal, data.gouv.fr, which you might have seen if you're into open data. It was launched in December 2013, and work on it started in June 2013. Now we have 22 state startups, and I will walk you quickly through 2 of them so that you get a better understanding of what I'm talking about. So our first example is a web application that helps citizens know which social benefits they are eligible to. The base friction that we're trying to solve is that of non-recours, which is people not claiming benefits they are entitled to. For example, in 2008, we had 80% of people who were eligible in France to a complementary health insurance, and 80% of them didn't request their right to have a complementary state insurance. So after several months of research, the administration was able to identify the reasons why there was so many people not requesting these benefits. And one of the reasons identified was administrative complexity. So they were able to construct some meta rules for the eligibility, and that ended up with a huge new paper form that would supposedly make it easier for people to access the benefits, which obviously was not a much simpler solution. Filling in more paperwork didn't end up being quite a workable solution. So we incubated a state startup, and that state startup is online. The application has been available since September 2014 and was made by a team of less than 2 people full-time. So under 6 months, what they built was a very simple form where you just enter your age, nationality, you describe your family, your income, and possible rent. And then at the end, we give you an overview of all the social benefits this person, the situation you described, is entitled to. So the first version that was in construction for under 6 months was introduced by the President of the Republic and had 7 social benefits in it. And we were covering about 80% of the nominal cases. The more exotic cases were not covered at the time. But we still had this online version, and we started collecting feedback and iterating over this, continuously delivering improvements. And now we are in this, what we call the consolidation phase, and we scale the service iteratively by increasing the audience, the scope, and also the partners. So what started as a 7 benefits thing now has 22 and has local entities, local governments also adding and contributing to this piece of software. So how do we do this? Simply by making everything public, iterating, and generating some interest in the delivery itself. So I can detail this more afterwards if you're interested, but we have many topics to cover. So, okay, I see you coming. It's, okay, the French are very obsessed with the benefits. This is fine, but of course, it doesn't scale to other problems. Not at all, because we can use the very same computation engine that's powering the social benefits simulator to estimate the actual cost of hiring a new employee in a company. It's the same open source engine that computes the two. So this widget is another state startup. It's the product of another state startup, which estimates the hiring cost, including all the taxes and financial credits that you could get for hiring someone. In France, and probably in other countries, but in France we do have quite a lot of different laws that may make this value change. So we just absorb all the complexity in one digital tool. So you can see that this widget, which was once again delivered under 6 months with a team of 1 person, this widget is extremely simple. Right, not very sexy, not something you would give away and make huge advertisement around. Well, of course, it's part of the strategy. We didn't want to create one new portal which would once again give only part of the information that employers or startups or SMEs needed. They already have so many places to go to get information. So this very simple widget is actually embeddable in the ecosystem of the employer. No new URL to know. The employer just goes to the administration he's used to interact with. Not only an administration, but also this is the same widget embedded, just one line of code drop-in inside a private startup that helps SMEs make their business plans. So now this widget is in more than 8 different partners, both agencies and private sector. And all of this was made possible thanks to it being free and open source software. So what is important to understand is that this tool can be used for free by any entity, be it an administration, an association, a commercial entity, even individuals. We create a digital common that makes law computable. However, distributing for free doesn't mean we distribute without any counterpart. We just replace the monetary counterpart by a contribution counterpart. So every improvement that is made by one of the reusers has to be made available to the rest of the community so that we keep on improving this common good that we're creating. And that's how we intend to scale the development of more exotic rules. This widget, once again, just like for the social benefits, doesn't cover 100% of all the cases, but it does cover 80%. And the private sector that is interested in improving their coverage and their services can use these 80% and then cover the edge cases for their own clients. And this will improve the coverage for the whole community. So I've talked about how open source allows us to open such services, but of course, we also use open data and open APIs. Actually, the creation of these shiny services from within the administration drives the public sector to understand the value of opening up. We are the first reusers. By building these services from within the administration, we use what's already opened, but we also request for more things to be open. And since we are these first consumers of internal data, we use this opportunity to apply best engineering practices, which means for web services to open APIs. So for those of you who wouldn't know, API is an acronym that means Application Programming Interface. The idea is to let machines access information automatically. And what's very interesting is that it allows for interconnecting systems that had not been designed in the first place to work together. So we all know that there are information silos within government. The one way to solve, to liberate these silos is to create a new service that will know exactly how to integrate with all these silos. That's one way to do it, but it's extremely expensive. Another way is to just open APIs on all these different silos, and then the new services that you want to create simply consume these APIs. So rather than trying to remove the boundaries between all the silos, which is costly, you just open the doors and explain very precisely how to enter that door, how to get information in and out, and you are able to create services. So I would like to walk you through a very quick demo of api.gov.fr that we introduced 2 weeks ago. Hopefully I can, yeah. Here we are. So you can do this at home too, if you're connected to the internet, of course. There's always the demo effect. So I have a version. No. If it doesn't work in 10 seconds, I'm using my fallback. Don't worry. It obviously worked before I started the presentation. All right, we're using the offline fallback. So, api.gov.fr looks like this. Sorry, we have not translated it yet. The idea is that we are listing the public and open APIs that are available. And you just look for the information you want to get. And obviously, since I'm not connected to the internet, you won't have the, oh, okay, so I'm using my roaming now, international, but anyway, what wouldn't one do to make this presentation, right? So, as you see, I'm just looking for a way to get the income of someone. So, I just look here for revenue, and I'm redirected to this description of this API, which allows me to get the information straight from the finance ministry as to what one person is getting. Under the last 30 days, with the services that we have already opened, we are already consuming this API. And this is the number of times where one piece of paper has not been filled by someone for information that the administration already knew about. As you see, this information, of course, the revenue, the income of one person is pretty sensitive. So it's open only for public entities, right? But it's still listed. So these APIs can be used by the public sector, but they can also, some of them can also be used by the private sector. So, for example, let's say I'm interested in the different regions of France. So you could have a look at the Geo API. So the Geo API is open for everyone here. And this is how it looks like. You have a list of all the different endpoints. And if, for example, you want to know what a zip code in France is for, you can just use this URL. And you get JSON back. So it's very, very readable by a machine. You can see that it's also readable by a human, but of course you want to create nice user interfaces over this. And the information is right here, right? I can do this, I can query for any zip code in France. This information is available for machines and people alike. No need to download a database. We're handling this for you. So we now have 10 APIs, and we obviously intend to open many more. Our aim with api.gov.fr is to make the state a platform, an actual platform. And this is how we are going to do it. We need APIs to liberate innovation and create new services. To create these APIs, we need to convince the administration that new services will emerge. That's the bootstrapping problem that all people in the innovation have been encountering for the past 4 years. And we are solving it by starting with the services and then making the APIs available to everyone. We are the first consumers. Okay, so I hope you got an idea of what we are doing with api.gov.fr. And I will just make a recap of what is a state startup, and then I hope we have some time for an exchange, because there are many other topics, and I think it's better that you ask questions, otherwise I can speak for 2 hours. So a state startup is friction, iteration, collaboration, and agility. There's nothing magical here, only a very different approach to risk management. Usually the administration is focused on reducing uncertainty, and we accept uncertainty, and we actually use it to reduce risk. That might sound paradoxical, just like it was a paradox to have a state startup. But indeed, more uncertainty means maybe an increased risk of execution, but we will know if we are about to fail much earlier. So we don't invest for years into delivering a service that no one wants, or that will fail because of some jurisdiction problems. So we're able to spot all the issues beforehand and to mitigate them. And for the moment, all our startups have been able to fulfill their promise of delivering a service under 6 months for limited budget, and we are getting more and more of them and opening more and more services and data. Thanks for your attention.
Matti, we repeated the poll. Who would have expected that?
I win.
John.
I win.
John, you know more than you could have known. Okay, 2 questions. I see John, yeah, and I'll throw myself this time into your computer.
Thank you. So the reason why I wasn't so surprised, fairly surprised by the presentation, was because it chimes really well with work I've seen in the UK government.
Yes, absolutely.
So we had a talk from the person responsible for transforming the UK government digital services. And just like you, their emphasis was on agile teams.
Yes.
So he had a slogan which was that it takes less time to implement a system now than it does to have a committee meeting to decide whether we should implement it or not. He reported great success, but especially in saving hundreds of millions of pounds in transforming paper services to digital services using agile platforms, and also shutting down useless government websites, which they proved nobody read at all. So I was wondering if you had the same experience of saving money at all.
Okay. So, Matti, do you want me to answer the questions now, or do you want to collect others?
Anyone up for a second question? I know she looks very, very hard at me, given the advancement of time. No, that's not the case.
Okay.
I think
Yeah.
it's a good question.
So there are quite a few differences with the great work the GDS team did. First of all, with the political mandate, right? In the UK, it started as digital first, and that was their mandate. I'm simplifying a bit, but so here it's quite different. As I said, we started with one state startup, then we had 2. Then we had 4, and we're actually continuing on this exponential growth. But we're extremely young. The official existence of our service dates back from September 2015. So I wouldn't be able to answer, because no, I don't think right now we are able to measure the impact of these services. Because very often we are framing them as innovation. So they are not there at first to replace an existing service. They are there to solve a friction that the administration had not been able to solve before. So it's very hard to compare an existing service with all its users with one new service that is trying to find its user base. I think as these services grow up and are taken back by their target administration, the target administration will be able to make choices and decide which parts of the new service it will use to replace parts of its previous legacy services. But we are not attacking frontally on the existing services. Does that answer your question?
Great, thank you. Who can smell coffee already? I can't. It's probably not even ready. We have a second speaker, and actually, I think there's good pairs in this session. So the first 2 presentations very tightly matched, more than I actually would have thought, and the 2 should also last. So here's a speaker from the UK, not from the national government, but from North Tyneside. Whoever knows where that is, but Ben will explain to us. That's Ben Kaner.
Explain it if people need it.
Who has a history from British Telecom's health division, but has returned to his home region. And the challenge is the same as explained by Matti, how to reconnect government to citizens, how to improve the actual service provision, and possibly how to do that in a privacy-friendly way.
Welcome. And yes, I feel the irony of speaking English in a European data conference given the news last week. My only claim is I live close to the Scottish border and maybe that will ameliorate it a little. Right, so data-driven government. What we're talking here is quite a simple challenge. First question for all government. Before we start on delivering anything, we have to ask the question, what are we here for? I will make no apologies for this having relatively little deep data content and being more conceptual in nature, because that is the point. We're trying to reverse the structure of data use in government. So we are here to enable our residents to be happy, healthy, and economically independent as far as is reasonably possible. Why would we do that? Well, if they're happy, they ain't bothering us. If they're healthy, they ain't bothering the health service. And if they're economically independent, we don't have to give them money. This is all good. If we can engineer ourselves out of a job, we have done our job well. So, well-ordered trade increases economic activity. If someone could please explain that to British population, that would help. Sorry, I have to say that. Good infrastructure for transport of goods and people increases markets and a pool of possible employees. I repeat my previous statement. Good schooling increases the total value creation available within the overall system, often done by government. Control over pollution, fraud, antisocial threatening behaviours is against oppression, slums, fear, and improves long-term outcomes. So I've got examples of the public health system. Very classic major governmental intervention in the 19th century with Joseph Bazalgette in London and became a model in many, many countries elsewhere. And of course, ensuring services available to those who cannot be fully independent, which is going to be us or maybe our children in the future. So don't forget that one. The challenge, I feel, is to switch the view. Data is owned by the individual, not by the government. Most governments and most organizations playing in this data field, be they Google or Amazon or Uber, want to own their data. And given kicking and screaming and legal implications, they may release a little bit of it back to the individual for where they really have to. But actually, hang on, it's my data. Why is it their data? Why isn't my data only shared with those I trust or whose services I use, be it from government or private enterprise? Why can't the incentives around sharing that data be around my needs rather than theirs? When I say theirs, I mean the government's need to, they want to provide health service. The particular part of the health service wants to deliver a particular type of health service because they've got a particular target involved. It may be finance industry trying to maximize their local profits. It may be the leisure industry, whether it's public or private, like public swimming pools or private leisure of various descriptions. Why are the incentives around their needs, not mine? Don't forget that in this infrastructure, it's a complicated arena. So it can't be every individual controlling all their own data. It involves, particularly where they're talking about the aged or the less able, you have to include carers or advocates within that system. So when you're handling data privacy, don't forget this is a difficult problem. This is particularly evident if you try and do anything within the health services, because if you have the slightly blurry microphone, if you're trying to work out who has access to what data within the health services, the person treating you, sometimes the patient themselves can't have access to the relevant sensitive information for certain psychological reasons. Is it their advocate? What happens if you've got a difficult family where the parents are estranged and data about little Johnny gets to the wrong parent and there's actually domestic violence involved? It's actually a very complex arena. But the principle is you own your own information. You share it where you wish in order to communicate and obtain services. And the sharing of information about you is transparent to you. So it's a bit of openness in how the data is shared. Now, this is a lot of words. Yes, I'm sorry, still again in English or Scottish or whatever. But this is a description of what an economic system is, which includes government, whether it's private, public, whether it's libertarian, whatever. It's a very simple Economics 101 statement about what an economic system is. If you go down this, you actually see that those who have power over that resource will tend to retain it. Government systems are based on an agreed compact of trade-off between the collection of revenues to support mutual services to enable the government to continue to govern. Military protection, roads, drinkable water, all those kinds of things, yep. Inevitable statement, evolutionary statement, all systems are subject to gaming. And if you game the system, you gain more power within that system, and if you gain that power within that system, you're likely to want to maintain that power within that system. That means any system that is stable over a long period of time will tend to end up with power concentrating in smaller areas. Yes, okay, that doesn't sound terribly libertarian, but in fact, without any turbulence, that is what has happened over the delightful fact that we've had peace for a long time. But given the fact that the government is constrained by the 19th, 20th century concepts of personal privacy, but the new information systems are not, you've got an imbalance. That imbalance, I think, mitigates against what was described earlier as a major purpose of government, which is well-ordered trade. So it's both a threat and an absolute requirement. Here's a proposal as to how possibly to help resolve that. Starting, yes, I know, in a local council. It's only got 250,000 population. It's not big. We're working within a region of 2 million. Okay, it's a little bigger. But we're doing it in a way that can be federated at scale. So, taking a deep breath. We're building an environment which involves all these blocks. Some of these are already in place. Some of these are being developed. So, personal data, I'll start with the supply chains. This is a traditional environment. We know what supply chains are, we know how they work, they're links, they're complex, and that's great. So that's our supply chain of services. Maybe public services like bin collection, maybe private services like shopping and consumer goods. It could be a mix of those. Care services are often in a mixed area. But at the moment, very rarely do we have a clear or standardized service catalog in any of those areas. If we have an aggregate, but if we did, we could aggregate those services into packages of services, classic marketing concept. A package of services can be marketed to a particular market. But in precision government, with the kind of data we're talking about, that market can be down and precise as one individual or one family. So we can package a set of services to enable a single family or single person to have exactly the right set of services around them to enable them to live their life, to enable them to be happy, healthy, and economically independent, which is our aim. But if you've got those data brokers and that personal information economy running, and by the way, when I say that, it says currently the figures are that it looks as though it's going to hit about 1 to 1.2% of GDP within about 5 years. That was before the turbulence. But that's a very big industry in itself. But if you have that information economy running, you can have consent to share, which gives you rich, identifiable, maybe pseudonymized data sharing. Of course, you've got the smart city Internet of Things, big data or open data coming in, also creating value. You can create pattern discovery across both the identifiable and the big data type arenas, which gives you incredibly rich material for your statisticians and your precision delivery of services, which you can also use to sell back to the organizations doing the supply chain for supply chain optimization. You can deliver policy and strategy, again, referring back to previous conversations, and you can do good market mapping if you're on the commercial side, all based on that consent. But most importantly and finally, if you have a system by which you can vet the algorithms that are generated by that analysis, you can feed that back to the individuals to provide personalized decision support. So, by the way, are we building all this all at once in North Tyneside? No. Essentially, we're going to do it in a particular order down the left-hand side, but making sure it's federatable. Expanding that, these are the technologies that we are using for the personal data stores. It's data broker based on Arduino NGCT's technology. I should, for the sake of argument, in case you notice that North Tyneside Council and NG is a partnership, and I personally am 50-50 funded by both. I'm a head of digital strategy for North Tyneside, but I am also 50% funded by NG at the same time. So identity brokers, yes, the Cabinet Office in the UK did do a very good thing with the setting up the gov.uk areas and gov.uk verify. We can exploit that for strong identity. The OIX forum is a good set of standards in that place. So the data broker is being built out under the auspices of the UK National Institute for Smart Data and Innovation, which is based in Newcastle, next to North Tyneside. It gives you an idea of where I come from. That allows us to do this absolutely critical part relatively easily and relatively cheaply. Interchange of data. I say 5G secured credentials. I say that says we haven't really taken a decision on how we're going to exchange. At first, we are delivering this data within our environment, so there's only one set of credentials needed. We have to accept them because it's delivering it to the individual in terms of their council data. However, if you know about 5G and telecommunications, you will also know 5G is actually more about the credential maintenance than it is in fact about the radio technology. Because you need to be able to have secure and verifiable transfer of information involving an individual, a device, and the organization to which that information is being transferred. We've got a data model for the individual's data, and the decision support algorithms that go with that will be, well, using the same model as we're talking about, as the guy from Gouv de France was talking about. That is exactly how we intend to provide our systems. So that goes down into the service aggregation and market making. So part of it is we are building a service catalog to create a defined services marketplace. Why would we do that? Because it needs to be efficient. We need to save a lot of money. That's one reason. The other side of that is that service aggregation traditionally has been by very clunky combinations of contracting, which tends to lead to large-scale outsourcing to single suppliers, often as a result of which a lot of money goes out of the local economy. We cannot afford that to go out of the local economy. We need local services. So by setting up that marketplace, we can retain a lot more value within our local area. And that still scales because, you know, if you want someone to cut your lawn, there's no point in them being in another county. Doesn't just apply to council services, because we're also working with the connected health cities to apply this to, for instance, health services. And by the way, the guy up here, some people may recognize as a doctor, but maybe not a health doctor, if you are feeling a little bit more geeky like I am. Don't say who. But then also commercial offers can come into the same marketplace because essentially it's exactly the same data. So if you're going from your own personal data, maybe you want another mortgage, maybe you want to rent a flat. It could be a council flat, it could be a private flat. It's the same information. Why do you have to type anything in again? Why do you have to expose any more data about yourself to one than you would the other? The supply chain below that, this is a technique called Wardley mapping. We're not really intending to address this directly, but we're intending to do it indirectly. But it's just a way of looking at what aspects of a value chain can be or should be commoditized and turned into utility, what are ripe for commoditization but it should at least be standardized, and what actually is quite specific and is going to need to be invented and supported. It's a very simple way of looking at the problem, but it has incredibly strong value when you're looking at your supply chain. And essentially, this is all about setting up a supply chain centered on an individual, but mediated by, in this case, public service and the council, but also by other parties, or rather than it having to be built from the supply end forward. It's not about the person supplying a service. It's, as the guy from Siemens was saying earlier, it's about the user of the service. So we will not be creating a new e-commerce marketplace, but we will be exploiting any supply chains we've got. We will be trying to accelerate the point at which the marketplace itself becomes a commodity, a series of commodities, so that we don't have to do it. Yes, it's going to be a little bit clunky when we start, but hey, you know, we have to start somewhere. And there's enough people playing around in this area that I believe we can make sufficient progress sufficiently quickly. And finally, seeing as this is EU Data Forum, the analytics side. Open data, organizational data, and personal information all can be brokered to retain the reasons and the consents by which it was collected. Open data, fine, it's open. Organizational data, they may wish to broker their data with other people in their supply chain or people within their field to create or innovate other markets. It's not just about the people or their government. But the personal information needs to be held and controlled securely. That's the whole purpose of the personal information economy. If you can, and you may need to pseudonymize the data, but you create an environment in which you get rich identifiable streams so that you know that you can link different aspects of data around a pseudonymized individual, but secured so that there is no way that information about that can get out to drive operational decisions by others. It's still available to the individual. Then you have a very different environment. Yes, you have the standardized anonymized research analytics, which is what government statisticians tend to work with. Commercial analytics, which we would like to be anonymized, but if you look at the way that big data mapping works, there is no such thing as truly anonymous big data patterns. They can find who you are. Ask any decent mathematician and they'll just say, given 30 pieces of data, they can identify you and probably your back teeth as well. And open research analytics, another immense part of data flow. But if you have that data broker and you have that transparency, you can have a transparency and contract for use back to the individual or the organization, or contract for the supply of data. Basically, you can create a marketplace in that data. But there's a feedback loop that we can create, and that is the vetted algorithms in the case of the personal decision support. And those vetted algorithms are what enable us to enable that happy and healthy and economic independence. Because what we're doing here is we can provide personalized advice to an individual or family, saying, if you want to be this, might be a pilot, it might be someone, a data scientist. I think they get paid more money than pilots. It might be a footballer. It says, or you are in this particular health state and you want to maintain your health. If you just want to be more attractive to your chosen gender of potential partners, whatever it happens to be, then it says, here's a set of paths that you can take to do it. This is the probable likelihood of success along those paths. And then you can choose, and here's some services to help you. Again, driving you back towards your own data. We've already done quite a lot of this. We've done Troubled Families Truth of Concept, which is about information back to the families to address particular people in particular areas who are going off a good track, becoming less independent and less happy and less healthy. How do we address them before it becomes serious? This is already in place. This is already working. Has already provided significant assistance in our delivery of this capability in the Northeast. Socioeconomic KPIs, this is part of the city's capability, which is delivered across Newcastle and North Tyneside. So you can map social economic factors with houses, buildings, their thermography. If you've got a thermal satellite and a 3D model, you can combine those to say what's the radiant heat of each building. Add in the power that goes into the building, you can calculate the temperature of each building, find fuel poverty and all those kinds of things. This last one's a little bit complex in terms of its picture, but essentially, this, if anybody's done machine learning or anything like that, this is just one example. I'm going to leave it to all the brilliant data scientists around to find different ways of using this. But this is a single transition of one system between state 1 and state 2. And this could be, I don't know, healthcare states where they've got a broken leg or heart disease or whatever. That's one dimension, one transition, 1 year, or maybe 1 month. And all this says is you're most likely to maintain state, but you'll start to, from that state, you're likely to go to this many other states of linked states. So it gives you a path through that over time. Even that one step for one transition is incredibly powerful. But imagine if you've got rich personalized data. You can have 30 or 50 dimensions of data all at once. You can have it over multiple linked transitions over a long period. And you can therefore track what's most likely to be a decent intervention for that person to maintain that target state. Possible nudges to improve the likely path of outcomes for all individuals, the vetted algorithm. That's just one example of how you can use this. I'm sure people can come up with others. So, yes, it's a long road. There isn't a real option. We have to have our local assistants to be happy. We're having enough trouble when they're not. We need to have access to a vibrant economy. But the way we're doing it, because we're starting with our own stuff and then working outwards from there in a federatable way, is allowing each stage to generate value. By doing so, we are not going to, hopefully not going to hit the classic problem of pilotitis, is we're only doing it so far and then we have to stop and start again. We're doing it so that each stage has its own value. So, and with that, I'm out of time, so thank you very much.
Thanks very much, Ben. Everyone has a right to a coffee, but you have a right to a question. Or you have a right to a question, at least one, if you may. There I see a gentleman. Yeah.
How do you see the impact of the general data protection regulation on your project?
The impact of the general data protection regulation on the project, just repeating the question.
Yes. The impact of the general protection regulation, well, if you have transparently consented to your own use, the use of your data, it doesn't apply, because you have transparently consented and being able to maintain control and withdraw consent to the use of your data. And that's something we're building in. Or at least it does apply, but it is completely satisfied by that criterion. Essentially, in one sense, that's what it's built around.
So you're saying it's privacy by design?
Privacy by design, yes.
And even by default, maybe. No, great. Thanks a lot. I mean, you have a right to a coffee. This was an extremely interesting session. I hope also for you. Thanks to all the speakers again. A big applause. And next session starts at 4:15.
Right. Thank you very much for the introduction and for having us here. I'm here representing the University of Southampton and the Open Data Incubator for Europe project. And because we're an incubator and our aim is to build a community, I am here with 3 of our most valued companies to deliver this presentation together. So besides me, there is Paul, Victor, and Clemens, who will tell you in a little while about how open data helps them create added value in various areas, in education, for smart cities, or in the legal domain. Let's just start perhaps with a short presentation of what ODINE is about. And I assume this little device here helps me with the slides. Yeah. Right. So imagine you have that amazing industrial data space architecture implemented. There is one particular type of data resource in that space that you can use right now. You don't have to sign any NDAs. You don't need to agree with your business partners and your data providers about the terms of use of the data, about how you are going to share profits when you create added value from it. Well, open data allows you to do all that. And there's been significant investment in each European country to publish valuable data assets from pretty much every industrial sector or area of the economy, of the society, of science, in formats that allow it to be easily accessed and reused. ODINE is about building a business, an industry-driven ecosystem to make more out of these resources. There are hundreds and thousands of data sets available in the open domain already. What we want to do is to help businesses, in particular startups and small and medium enterprises, which are the engine of growth of the European economy, to make more out of this data. What do? We're a Horizon 2020 project, which is split into 2 parts. A third of the project is used, the resources are used to build a program that helps the companies to thrive. 2/3 of the resources are used to organize a competition for European startups, for European SMEs that have great and exciting and high potential ideas on how to use open data, possibly in combination with shared and proprietary data, to grow a business. So we have launched a call for business ideas around open data last year. This call is still open, at least until August this year, potentially until October as well. Every 2 months, we take all submissions we have received and evaluate them with the help of external experts, both from the entrepreneurial domains, but also people who know about open access and data-driven technologies. The winners have a chance to join the incubator. They receive up to 100,000 euros equity-free funding, as well as a number of services, which are displayed here. So, depending on the type of company, depending on their stage of development, so from early stage SMEs, micro companies, to established companies with 100 or 200 of employees, we offer custom expert advice from business mentors, from advisors within Odine, to help these companies do more with open data. We set up a community, we offer peer networking and support, we help you with promotion. We work together in a media partnership with The Guardian in the UK, who helps company advises them in how to bring their message across to their audiences. And we offer various types of events and introductions to investors. As it stands, we have 34 companies in the incubator. Some of them have already graduated, 2/3 of them are still through the program. We have invested 3.5 million euros in these companies from 14 different European countries and various industrial sectors. And you'll hear 3 examples of these industrial sectors later on. There are a few other companies in our program at our stand on the 3rd floor, and there are a few others that are presented on the Guardian website, where we have set up a microsite called the Open Data Economy, or at the stand that the project has on level 3. So 34 companies from 14 countries. These companies have already generated more than 1.5 million euros in additional value. We measure impact by the number of additional jobs we have helped created, by the additional sales contracts that these companies have generated with the help of the funding and the services we offer, and by the additional private or public investment that these companies have been granted access to. So already at this stage, 1.5 million euros in unlocked value. What is the funding for? Well, business ideas using open data to create things that matter. So we put a strong emphasis on something that we call the triple bottom impact. So it's not only about profit, it's also about the people and the planet. So you will see some of the companies that we are incubating operating in areas like the circular economy, the sharing economy, the environment, agriculture, and so on and so forth. You can use the 100,000 euros for a variety of things, from funding employees or paying salaries in general, to all sorts of infrastructure, equipment, trips to customers, travels to events like the EDF, subcontracting to other parties that would help you grow your business, pretty much similar types of expenditure like in Horizon 2020. It is all custom and tailored to your needs. So you tell us when you submit an application, what would you envision using those funds for? Now, what do you have to do to apply? 4 simple steps. So from the top of the stage, go to opendataincubator.eu. On the front page, there is an area called Apply. If you go there, there are all sorts of documents and guide-throughs available that help you understand how the online submission is handled, what types of things we are looking for, what kind of templates have we put in place for you to compile your application. After you've learned how to apply, prepare your proposal and apply online. Evaluations are run every 2 months, like I said. Within a month from the submission, you will hear back from us. In this month, we have a 2-stage evaluation process where around 20 to 30% of all applications are invited to a 2nd stage interview with a panel. And then, based on the numbers we have seen so far, around 10% of the candidates are invited to join the incubator. Once a company succeeds to pass this stage, there is a 1-month time frame to sign a contract with Odyne, after which you are granted access for funding and you have access to all services that you need. If you go to the Open Data Incubator website, we have put together a simple dashboard that gives you insight into some of the statistics. So you can go there and see where do the applications come from, what are the different success rates across the different rounds. So around, as I said, every 2 months we evaluate the submissions. This is what we call a round. You can see the areas, the sectors that the companies come from, their countries, and the amount of funding that we have granted. So this is for you if you're interested to see where the applications come from, and also to get an understanding, perhaps, of the development stage of open data innovation across Europe. What you can do next if you're interested, so this is ring 3 on the spaceship. We're at stand number 26 over here. There is a mailing list you can subscribe to if you visit the website, or you can ask questions on Twitter or at call at Open Data Incubator. Submissions are online, as I said. We're also going to be present at the Open Data Institute Summit, which is one of the biggest open data events in Europe. Last year we had 600 or so participants. It's based in London. There we will have a stand similar to here, and most of the companies, we hope you will be able to join us, and you can meet them there. All right, so this is us, perhaps last but not least. This is a collaboration between the University of Southampton, the Fraunhofer team that Søren is leading, the Open Data Institute in London, Telefonica, WEIRA, which is an accelerator based in Spain, the Open Knowledge Foundation in Germany, Walter is sitting over there, and our media partner, The Guardian. So this is all from me. If you have any questions, we're on ring 3, and now I will pass the word to my colleagues who will tell you about how they change the world with open data. Thank you very much. So I think we're going to start with Paul. The slides are there.
Yeah, my script's here. Thank you. Can you hear me? I'm supposed to use this. Oh, now I'm supposed to use this. Okay. Yeah, that's me. Great. I'm Paul. Nice to be here. Thank you very much, Elena. And thanks to Odyne and our partners. They include the City of Amsterdam. We're based in Amsterdam. And the IoT Living Lab is an Amsterdam project. They were the first funders of the project, co-developed with the CTO office, Ger Baron. Maybe you're familiar. And the whole school from Amsterdam, the University of Applied Sciences. And recently, maybe you know that Amsterdam won the European Capital of Innovation Award for Europe, which was partially due to our work, our collaboration with the community, and the open data community, and the sense-making community. So we're dedicated to creating Internet of Things infrastructure for open public spaces in the city. And around those IoT open infrastructures, there is a whole data generation program that engages public spaces and people and developers to generate value across all verticals. The reason why we talk about open data and we invest in open data as the IoT Living Lab and the City of Amsterdam is because of the huge growth. Of course, if you know the statistics, the growth in IoT is going to be massive and contribute to over 20 trillion gigabytes of data in the year 2020. And we want this data to be open because open data is valuable data. And open data also stimulates local economies. And we work with JC2Co, and we work with the City of Amsterdam with mobility in the bus and tram stops to help with public transportation applications, real-time data. We work with the Vox Society on air quality sensors, and we're also working with the Marine, which is a new innovation hub in Amsterdam, where we're monitoring water quality to make it so that we can make people aware in Amsterdam that they're able to swim the canals. It's healthy, it's good. And other verticals, I don't want to take up too much time because I have other colleagues that want to talk about their projects as well. But recently, I want to talk specifically about a project we did with the whole school from Amsterdam where we gave the Oosterpark, a park in the city, a personality, a way to speak to the people and a reason to communicate and engage the public and to attract them to the park and to encourage them to come out of their houses and into the park and stimulate exercise and social activity. This is a new project by the whole school from Amsterdam called Bambia, Beweging in het Park met Beacons, translated into moving in the park with beacons. And that's growing. We're going to install 25 LoRa, which is low energy, long range M2M protocol beacons by the end of the summer, and more sensors as well. We are creating with the Marine Sharina, the new innovation hub, and the Makerversity, which are our new tenants of the innovation hub, the Marine Sharina Living Lab, and we're expanding the IoT Living Lab, which now incorporates the entire city center. So we have over 300 beacons and sensors installed in the city of Amsterdam, which are open data and which developers use to create third-generation IoT-enabled interactivity. And this was also an inspiration for the Things Network and for an app called Art Whisperer, which is featured on the National Geographic Explorer program. You can watch July 1st. And there's a lot of clever and interesting innovations out there, and there's a big knock-on effect on the economy. And the impact we're having on the economy is significant. We're talking about millions. And we like to say that we're not just creating infrastructure, we're enabling the city with the Sense Network to create a sensitive city. We want to create cities that have a way to feel. They sense things, and that they generate open data. It stores that data. It can create models with, of course, the help of the public. It listens because we're implementing social validation platforms to give that data more value. It interacts with people, of course, and of course, it shares that data and collaborates with other cities, and we learn and knowledge share with other cities. Our next city is Helsinki. They've given us an approval to go ahead with that program. We're talking to Paris, Leeds, Berlin, and Zoetermeer. Thank you very much.
Good. Can everyone hear me? Yeah. So good afternoon, and thank you for inviting us. I'm Victor Pasquale, and I'm here representing Series Academic. Series Academic is a consultancy firm in the sector of higher education and research. So thanks to Odine, we had the chance to start building our platform called UNIX, which stands for University Analytics. So higher education and research institutions are under unprecedented pressure. We know that there's an increasing competition due to globalization, so universities need to not just to compete against universities in the same region, but also in other countries. There's an increasing need of industrial partnership, like when you want to get a project of Horizon 2020, for instance, or something like that. Yeah, it's important to understand who are the best partners for you. Or another example is that there's an increased audit in public scrutiny processes to account for public spending. So we are aware that our customers need evidence-based decision-making tools, and they need people like us, which are experts on the sector, that tells them how to take better decisions. So what have we been doing during the last 8 years? So one way to benchmark a university, for instance, is to use university rankings. You know that there's several university rankings out there, and those rankings use different metrics. Sometimes it's quite difficult to understand what those metrics mean because we don't really know where they got the raw data. But we are definitely aware that there's data out there. There's open data out there that can help us, can help our customers to understand, to provide context to these metrics. So this is what we're doing in Unix. In this case, what we want to do is we want to convert data into real decision-making tools. And what we're doing is we're developing this layer. I'm not sure if you can see it properly, but this layer here, which is a semantic platform, which is core, it's an ontology that models our sector, the higher education and research sector. So what we're doing is we're actually investigating all the data sets that are out there, and there's thousands of them. I mean, there's open data sets related to higher education and research of universities, of ministries, of evaluation agencies, and so on. So what we're doing is we're actually listing them, and that we're connecting them to our system. So we can then provide analytical solutions. We are also expert in data visualization and data integration indeed. So we can develop very specific tools to solve very specific problems to our customers. So these are just a few examples of the tools that we have been developing. We've got a visualization of rankings. We're actually working on a project that actually takes into account, analyzes the aging distribution of scholars and researchers in Italy, to actually tell our colleagues, our customers in Italy, when some of the scholars are going to retire and when they should start planning on hiring new people, for instance. These are topics that, as far as we know, no one else is dealing with. And these data, integrated with GDP of the country, investment of the region in research and so on, it's extremely powerful. So what we're doing is we're putting all this data together with this ontology, and then in our website, which is university-analytics.com, we're going to provide a SparkQL endpoint so anyone can actually use this data. On top of this SparkQL endpoint, we're creating our own analytical tools, our own visualization, which is actually what we sell to our customers. Finally, it's important to stress that some of our competitors, what they do is they have their own ranking. So they are attached to this ranking, to those metrics. We are actually independent from that. So we are objective. We're definitely objective. We're open by default. That's why we have this SparkQL endpoint so anyone can use it. We are aware of the organization complexity because we've been on the market for the last 8 years working in Europe. So the most important part is that we offer an integrated expertise. This expertise is not just, this integration is not just about data, it's about integrating data with the expert that know how to deal with this data and the expert that really understand this data. So this is all. Thank you very much.
Hi, hello. My name is Clemens from Open Laws. We're a legal tech company based in Salzburg, and we're dealing with legal information. So legal information has become popular last days, last week, Article 50, Treaty of Lisbon. But the point is everybody has legal issues. Everybody has to do with the law. If we have an event here, it's about organization to stick to the law. So what's happening right now that legal information is also becoming open data. So what can we do with it? Our first customer is Sony DADC in Austria. And they came to me and they asked, well, you know, we want to do the ISO certification, and we need to deal with legal information. We want to keep up to date. We want to know what's changing. We have to deal with all that regulatory framework. But that's a problem because, well, there's databases, but we need to have a little more. We need automated notification when something changes. We need to work together with our lawyer, etc. So, and that's when we come into the game. In order to stay compliant for the company, especially also for the bigger international companies with multinational law, to save cost and to reduce the risk also for directors and officers who might be at the end of the day personally liable. So we really combine the area of law with open innovation and open data. And open data is kind of the material we work on. And open innovation as the broader concept is really to bring the community together. As Elena mentioned before, it's a good combination to something good for the company, but also to do something good for whole society, because legal information is something that affects everybody. So we can come up with one solution that sustains our business for the bigger companies in terms of providing legal information, and we come up with free legal information, which is a thing that matters. So this pyramid, you might know that information pyramid, it's based on open data, so that's the broad basis. We import that. Important thing is we import it from several countries from the European Union. So we have a data model that is capable of capturing data from different countries. So we have one database that catches it all. Then we put legal tag, legal information on top. So we analyze this large amount of legal information. And then we have the open innovation and knowledge part where people can actually work together. You know those graphics, just perhaps for you to know, we use Neo4j, which is a free and open source graph database. And we use Pool Party. This is also a module that the Odine program finances for us so that we can build a legal knowledge graph to analyze the legal texts that we have. Right, so at the end we come up with legal data that is personalized, which is catered to the needs of specific companies. We integrate data from different countries, and so if you are a country, if you're a public body and you have legal information which you want to integrate perhaps also within open laws, because then you can use the features of open laws like highlighting text or bookmarking, etc., then it would be great if you could come to me and speak with me. I'm here tonight. I'm also at the stand 26 with Odine. Or if you're a company and if you have legal questions, so would also be great to talk. Thank you so much.
Right, so like many things going on in the UK at the moment, I haven't quite thought this through. So I wasn't quite sure how we're going to organize this Q&A session now with 4 people and 1 microphone, but let's just start and learn as we go along. So if you have any questions to anything that you have heard, program or companies, just raise your hand and then we'll pass you the box. Yes.
So you've seen over 600 applications from 14 different countries. So are there any striking differences between the different countries?
Yes, thanks for that. So just to clarify, sorry for the confusion. So the 14 countries are the countries of the companies we are funding. We have actually seen applications from every European member state, almost 600, as I said. There is a huge amount of diversity in the number of submissions, in the acceptance rates, in the type of business models and sectors that these companies address. Some of them have definitely to do with the degree to which open data is a topic in that country. So we have seen lots of applications from France, we have seen lots of applications from the UK, we have seen lots of applications from Spain as well, and perhaps less from countries where open data is perhaps not so advanced. So that's definitely a factor. Then in terms of sectors, obviously because we focus on this broad impact, a large share of the applications do have a societal or environmental component. However, we also have very successful companies that operate on commodity markets in the financial domain, that build tools to understand better statistics data from Eurostat. So there's variation, but there is definitely a focus on environment and society, on broad impact. So I think these would be the two main things. So how well, perhaps a third one would also be what I would call the innovation mindset in particular countries. So we all know there are European versions of the Silicon Valley in some parts of Europe and perhaps less in others. And we see that reflected quite clearly in the number of submissions that come from those areas. Thank you. All right. So everyone wants to start the party now. Thank you very much for your attention. Oh, right. There is someone who decided to ask a question.
Should I start?
Here we go.
Sorry, I did not get the first part of the question, the privacy issues, the second? So we get legislation and case law, but it depends on the country. So the level of open data is different in each country. UK is very good, for example, in legislation. Case law is a problem in the UK for open data. Austria has both. Germany has legislation again. So our main focus is really on legislation. The other question is privacy. Yes, that is a concern which is constantly discussed, especially when it comes to case law, because the names of the parties are in there. And also the names of the judges and the lawyers in there. Typically in the legal domain, and that's also the approach of the European Court of Justice, that the parties are anonymized and that the lawyers stay in there as they are, because the argument goes, it's their business, it's their job, it should be known what they do. But this also raises interesting questions, because what could you analyze then? Yeah, and that's all new questions.
All right.
Another question.
Yes.
Another question for Open Laws. I'm sorry, but I failed to understand precisely. Are you helping governments augment their law and then distribute the databases, or are you providing services based on augmentations of the law that you would keep private? What are the intended benefits for? Because you asked for public entities to collaborate with you, but if then you are only extracting private value and keeping the database for yourself, then I don't understand exactly.
No, we don't keep it for ourselves. So the time frame is short, and it is really a complex picture. So we want to integrate open data from the open data sources from the different member states, and we're speaking with several countries, because the idea is we're building legal infrastructure for Europe. And there is some functionality which everybody could use, like this personalization. It doesn't depend on the legal system, it doesn't depend on the jurisdiction. Everybody could use it. Why reinvent the wheel 28 times? Doesn't really make sense. So our data model is set up to include the different ones. And there's ideas like highlighting information and some personalization features that everybody could use. So if we combine that, if we combine the national databases with open laws, then the citizens have this free access to those other tools. And because we have the split, there is this free part which will be free, which is the social venture part of open laws. Citizens of all those member states directly benefit. And then businesses and lawyers have other premium features which they need. But it's also fair that they pay for that because they also charge a lot of money for that. So therefore, it's kind of a Robin Hood business model.
All right. Oh, there's still more. Is this okay? Last question, and then Will take over.
Sorry, very short. Do you plan to do some artificial intellect which can provide legal advice on your database?
Legal advice on the data? You mean like replacing lawyers? No.
Yes, like replacing lawyers.
Well, yeah, The End of the Lawyer. Good book, Richard Susskind. Everybody should read in that area. No, we're not replacing lawyers. What we do is we want to automate things that should be automated. Like you would not want to read every piece of legislation and notify each company when there's some change. That's not the task of a lawyer. A lawyer should focus on what the lawyer does best, solves cases, etc. But we focus on what you can automate, and this certainly goes up, and you can do more over time. But you will not replace the lawyer. So you will make the work easier for experts, both general counsels within large corporations, but also for the lawyers, and help them to do the big data analysis, what you wouldn't want to do manually. That's what we do.
Okay, so this was a very interesting slot. I think it was like a session in a session. So I suggest that we first thank Elena and her team. And as you can see on the slide, we have now reached the most important point of the day. So you go to conferences partly to go to talks, but I think the most interesting thing is to meet new people and to change experiences and make new connections. So what we will have for the rest of today, we first have some drinks. Then there will be the presentation of the Data Innovator Award. Then we have the first EDF pub quiz. So this is to test your real knowledge of data. So don't be scared, really go there. And then we will have a walking dinner with the barbecue. And I hope you will enjoy the evening very much. Thank you very much. Okay, a very warm welcome to this session on smart industries. So there have been some last-minute changes. That was why I was running backward and forward. So we have 3 slots in this session. The first slot on smart industries will be given by Grete Coldevin. I'm sure I pronounce your name in a horrible way. And she's working as a director of the Norwegian Smartgrid Center. And this is a very interesting initiative, a center which is founded by its 50 partners, and I'm sure she will tell much more about it. And it's very interesting, I think, to see how data, the availability of data, is changing the energy sector completely. So the floor is yours. And let's give her a warm welcome.
My mission here today is to draw attention to the energy sector as a key sector in data-driven innovation. And it's a bit late now in the afternoon, but I have heard that the people here in EDF, they have stamina. So I hope that you are with me now, finding the energy to listen to my presentation about the energy sector. A few words about the Norwegian Smartgrid Center. We have 50 partners from the power industry, the ICT industry, and from R&D institutions in Norway. And the center is funded by this partnership, and it's a non-profit organization. We coordinate the Norwegian Smartgrid technology platform for in Norway, and it currently consists of 8 power industry-led and driven demonstration sites, and we have 1 Smartgrid laboratory at the university in Trondheim. Internationally, we collaborate with the European Smartgrid technology platform. We also collaborate with the International Smartgrid Action Network, which is organized by the EIA. And we also collaborate with the Global Smartgrid Federation. One of the obstacles when working with data-driven innovation in the energy sector is the complexity. As you can see here, we have a complexity in the different sources for energy. It's coming from hydropower, solar power, wind power, bioenergy, gas-fired energy power plants, and so forth. And we have all the different ways of transmission and distribution of the energy to the different end sectors, and the end sectors are using energy in different ways. We also have a complexity in the energy sector with regard to other countries. This is just a map of Norway in 2015. Here we are today with interconnection to other countries. And in 2050, we expect much more connection to other countries. This is a source for data-driven innovation, because as the electricity is flowing to other countries, we also need more data and more surveillance in order to control and operate the electricity system. There are at least 3 major integration trends in the transformation of the energy system of Europe. First, the consumers become active and is put at the center of the energy system. The second trend is that there is an energy demand focus now where we have to increase the energy efficiency across the whole entire value chain in the energy system. And we need an energy system optimization so that we will have a secure and cost-effective and also sustainable energy supply. Changes in the energy sector is by and large driven by policies and regulation. As you know, in Europe, by 2020, we're going to have 20% of renewable energy in the energy mix. We're going to have 20% energy efficiency by 2020. And we are going to have 20% reduction of carbon emissions. Often people in the energy sector where I come from, and I'm not a computer scientist, I'm a mechanical engineer, and I work in this sector for several years. Often we start out talking about energy, but we soon end up talking about electricity. And I will also do that. Because, as we see in these global studies, the electricity demand is outpacing all other final energy carriers in a 2050 perspective. And within this global outlook towards 2050, solar power is seen as a dominant source of energy. It also emphasizes electrification of transportation and the developing of electricity storage as major challenges in this time frame. This year, a new edition came out, and here the cities takes the center stage of the future energy system. The cities are drivers of sustainable innovation, and they are pushing the limits in key areas. The last 5 years, it has become more clear that ICT technology may enable substantial cuts in carbon emissions. I have noticed that actors from within the ICT industry itself makes a stronger case now than 5 years ago that data-driven innovation should not be overlooked with regard to decarbonization of the economy. For example, this study, the GSI study, looking at the perspective from 2015 to 2030, it analyzes that ICT is likely to have the biggest abatement impact in 4 user domains. It's the smart manufacturing, the smart agriculture, smart buildings, and smart energy. But let's take a look at Europe. 10 years ago, in 2006, the European Technology Platform for Smart Grids gathered 150 experts. And we made it together this compendium. And here we looked at what was the drivers for the electricity system development by 2025. This year we had a summit again, and we released a new report looking at what are the challenges for the energy system electricity system in 2025, and are they the same as we saw 10 years ago. In 2006, the drivers creating a need for a smarter electricity grid were the aging of assets in the grid, increased electrification, an increased share of distributed renewable energy resources, and the need to secure a reliable supply with regard to energy to the consumers. In 2016, the argument is that all the challenges from 10 years back are still valid, but there are 4 new opportunities/challenges that are added here. The first is the customer-centric energy perspective. The other one is the need to create the storage technologies and to reduce the cost of those kind of technologies. Then there is the communication technology platform for the power sector. And at last, the Internet of Things and big data. So I mean that the energy sector now is at a stage where IoT and big data is explicitly recognized. Before, it was more implicit in the challenges that we saw for the energy system. The IEEE connects 70,000 energy scientists worldwide. They have made this compendium for smart grids in the next decade. And here we see that globally, the scientists share a technological vision of a very highly instrumented overlaid electricity system with advanced sensors, computing, and that has enabling platforms and technologies for secure sensing, communication, automation, and control. IEEE has described or made this conceptual model of different smart grid domains, and this shows a bit of the complexity of the energy system. First, electricity is not anymore going to be transmitted from the centralized power generators to the end customers. It will be so that electricity is generated at the premises of customers themselves. The customers are becoming prosumers. This model also describes how data is not only a matter for the different domain within the grid itself. Data is going to be provided amongst the different actors operating in electricity. And this makes a case for both decentralized data processing and also for the creation of foundational support system that can serve different domains within the smart grid area. A few years ago, the utilities in Europe began struggling with a relatively modest introduction to big data as a consequence of the meters going to be rolled out in different European countries. Before, we have had about 12 readings of the energy use for consumers a year. And with the smart meters, the utilities are getting about 8,000 to 10,000 data points per customer per year. And in addition, the smart meter is including the measure of power quality, voltage variations, 3 phases of currents, phase breakage, and also tampering with meters and temperatures and so forth. So we see that the industry now has gone from a handful of data points per customer to tens and thousands or more data points per customers. This is just an illustration from Norway. We will have 3 million smart meters by January 2019. And before, the control centers in the grid stopped at the substation level, and we had no way to observe what was going on in the low voltage grid. This is changing now. In Europe, it's estimated that there will be 200 smart meters for electricity by 2020. And we will also have about 45 million smart meters for gas. This table is just an illustration that it doesn't stop with smart meters. By 2020, we expect a huge growth of data in data coming from other smart devices that are going to be installed on different levels of the electricity grid. The point by showing this GE report from 2015 is that the growth of data across the entire value chain in electricity is growing. But the application of big data technologies is in its very early stage. It is yet to be demonstrated what will be the system-wide impact if we start using more of the different areas of big data technologies. We see that there is a variety of technologies available today, but it is not easy for the electricity actors in the energy sector to find out which of these technologies is going to have the largest impact on the business, on the daily operation, in planning, and also what can contribute to a change of the business model in the industry. So we need a mapping of available big data technologies across the electricity value chain, and we need to find out which use cases across this value chain is big data relevant. This figure is one attempt to sorting available technology across big data areas at the one hand and across the electricity value chain at the other. So in the blue, there is the electricity value chain, and vertical here is the different big data areas. And as I said, we also need to define better what are the big data relevant use cases in the sector. I have included a few examples in this presentation. For people who are interested, you can read a lot of the different use cases in this report. One of the areas is that we see that big data will increase the predictability of distributed and variable power generation. We have to be better in forecasting how much power can we get from solar, PV installations, how much energy can we get from windmills, and how is that going to be supplied to the market and to get a price that is right when compared to the demand in the marketplace. So being able to combine data sources, meteorological data, measures of local weather conditions, measurements at the different plants in operation, also drone images, this kind of combination of data in order to be better in prediction is a key area in the energy sector. So big data can be a great value for activities such as allocation of balancing power, the optimal scheduling that we have to do, to handle congestions in the grid, for making the trading of electricity more efficient, and so that we can be able to come up with advanced bidding strategies in the electricity market. And one of the new business models in the energy industry is the operation of batteries in order to balance demand and supplies. This is an emerging field, and there are several small tests done across Europe, but we need large-scale tests in this area in order to actually see the impact of batteries in the energy system. Another area is that we think big data technologies may allow us to operate the transmission, the high voltage level of the grid, much closer to its true operating limits. The value here is enabling the transmission system operators, the TSOs that we say, to enable them to maximize the utilization of the transmission capacity. Data sets are made available nowadays. There are new units coming in. One of the important ones are synchrophizer measurement units. With such PMUs, when we install them in the grid, we get a wide area observation of the grid and the condition of the balance of the energy and supply. Such data can also provide us with early warning if there are grid disturbances. But we need that these kind of data are put to use for the operators in the control centers. So we need advanced visualizations that synthesize this kind of information and that really improve the situational awareness of the grid. The last point I would like to make here is that we think big data technologies may enable a much higher degree of automation and to remote operation of the low voltage and medium voltage grid. Today, if there is any faults in electricity in the house of a consumer, they have to call the low voltage grid operator and to say, hey, there is something wrong. Data that are made available through the smart meters and also additional instruments that we are putting into the grid today are making us able to operate and to control the grid in a completely new manner. The industry will be able to provide the consumers and the retailers selling energy to consumers with accurate data of energy use. And we will also have consumer information and consumption and fault and interruptions that can be communicated through web interfaces. What we see also is important is the standardization of the fault detectors and the meters in order to do them to be able to remotely modify the meters through software instead of building everything into one hardware component. And that is a development that has taken a large step forward the last 3-4 years. And we also see that there is a functionality variation that are built into concentrators of data in the grid. And the real-time surveillance capacity of the grid is really increasing now. I have included a few illustrations on different types of visualization that we are working on in the Smart Grid Center. We have different teams that are testing different kinds of software applications. This is just an example from one of the grid operators showing that they have a really silos of data, historical data, in the system already, and now they are getting the real-time data from smart meters and other instruments coming on top of the silos that they already have. And what they really want is to have intuitive and seamless interfaces for the planners and the operators. These are just a few illustrations showing where we are heading. In this industry, it's very important to work with graphical visualizations and the topology of the grid, and to use colors and different ways of showing where there are faults and where do we have to take action in order to repair if there are interruptions in the grid. Also, we need visualizations where the customers have different kind of priority. If there is a blackout in Norway, we need to know where is the hospital, and they have to get the electricity back first. So these kinds of visualizations showing where we have trouble, what kind of customers are involved, and what action are the company taking in order to restore the situation is important. And these are new things coming now based on the smart meter data. There are many other important use cases that I have no time to go into. I just listed 3 of them. Predictive maintenance is an area where we can have a lot of experience from other industry sectors, I think. Then we have the customer load prediction and customer churn prediction, which are two other areas that we are working on in Norway. So I asked the expert in computer science that are related to the Norwegian Smartgrid Center to give some kind of concluding remarks with regard to big data in the energy sector. One overall message is that current energy applications are not taking advantage of big data technologies. We are just at an early stage. There are a number of big data technology stacks existing, but it's not possible to create one platform that meets the need for all the different steps in the value chain of electricity, or also that answers to the different use cases that we are working on. I also received some comments on the prescriptive and the predictive analytics inside big data. That let's see, yeah, visualization and descriptive, yes. The message is that to make data more accessible, not only the smart meter data, but other sources of data, is a huge challenge in this industry. And we know that it's a foundation for innovation. But we think that the smart meter rollout is a new source of data which can be combined with other sources and provide very useful new tools for the operation and the planning of the grid. As for the more prescriptive parts and the predictive analytics in big data, some of my colleagues, they are claiming that the existing approaches rely on rule-based systems and physical models. That's typical for the electricity industry. So there is a huge potential to use more existing generic machine learning solution and also advanced statistical tools. In particular, in areas where we have a much higher degree of renewable energy distributed on a lot of local generation sites, we need to be able to predict better, and we also need to be able to predict the load, how people are using energy. And we see that existing ICT solutions in the energy industry today are typically not able to handle the real-time sensor data efficiently. So here there are room for improvements, and we need demonstration projects in order to show where we can get impact from different available or maybe in the making big data technologies. So the ambition of the Norwegian Smartgrid Center, and we are working together with our Nordic colleagues, is that the region in the Nordic region is going to be, and maybe it partly is, a model region for a smart electricity system. In Norway today, the average consumption of electricity for one household is 16,000 kilowatt hours. If we compare that to the Netherlands, I have heard the average here is about 2,000 kilowatt hours. So we are an example already on an all-electric society. We also have 50,000 electrical vehicles on the roads. 95% of the electricity comes from renewable energy sources in Norway, from hydropower. And that's a variable generation source. So we already have some level of smartness in the grid in order to operate this kind of generation. So I will thank you for having me here today, and we would like to cooperate with our European colleagues, in particular in pilot and demonstration projects. We need more of that in the energy sector. Thank you very much.
Thanks very much, Grete, for this, I think, very nice overview of the impact of data on the energy sector. So we have time for some questions. So who can I invite? Otherwise, I can kick off myself. So if smart metering is mentioned in the Netherlands, there are often big privacy concerns that burglars can see when you are away. You didn't mention this as one of the challenges.
It is one. I think it would deserve 1 hour in itself, that topic. And we have regulation, 3 different types of regulation coming into the privacy of data when it comes to smart meters in Norway. And I understand that people are concerned because it's a way of surveillance. It's that. So we have to make sure that the data are not coming on the wrong hands. Yeah.
So you said there are like 8,000 data points per household per year?
8 to 10,000, yeah.
Yeah. And
that's only the energy use. Then we have the other data points, voltage, power levels, faults, interruption,
But you're trying to, by securing the data, that's the approach that you're using towards that?
It's one of the issues, and we have to find ways of doing that in a good way.
Yeah. Thank you. Other questions? No? If not, then you were very clear, and I propose that we move to the next speaker. Let's thank Grete again. So the next talk will be given by Søren Auer. And he has a dual role. He is head of the Enterprise Information Systems Department at the Fraunhofer. At the same time, he's a professor of Enterprise Information Systems at the University of Bonn. He is very active in many European projects involving data. His group also developed DBpedia, SlideWiki, linked geodata, and OntoWiki. These are all kinds of applications that are widely used. He is also, and you may not know that, he's also the chair of the steering committee of this very conference. So he's very well connected with this community, and I'm looking forward to his talk. Let's give him a welcome.
Thank you. Thank you very much, Will. I'm very excited to be here and to be able to talk about something we kicked off a while ago in Germany, which is called the Industrial Data Space, and we now would like to enlarge that. It is a German initiative, but now is the time to also involve more European players, and that's why I'm very happy to present this initiative here at the European Data Forum. So what is the reason for this initiative? So we have the Internet of Things, and on a lower level, which connects sensors and devices, maybe also production equipment in shop floors and industrial manufacturing scenarios. And we have smart services, which on the top level realize maybe new business models. But we think that there is a layer in between missing for managing data between these two layers. That's what the industrial data space is about. And of course, it's about digitization of economy, of business. We have heard a number of examples in the beginning today. One more example here, for example, is running shoes, which previously were sold as a product. Then there was a classic service developed on top that you have a training monitor. And once you can combine that with a social network, you have something like an ecosystem which involves not only you, but also your friends, your family. So you have really smart services on top. But it also requires that we can exchange information between different organizations. We have, for example, the producer of the shoes. We have possibly cloud services. We have the producer of the smartwatch. We have services, the social network. So we need to make data accessible between different providers, between different organizations. And these new digital offerings, they follow certain common architectural principles. So we have a decoupling of physical platforms and products. We have different architectural layers which are also decoupled. Platforms become products and vice versa. Ecosystems develop around platforms. And innovation is also done in a cooperative way. So there are different organizations involved which collaborate around innovation. So we need to connect data along a whole data value chain, which involves production networks, logistics networks, smart manufacturing with aspects like human-machine collaboration, interoperability, autonomous system, Internet of Things. On the services side, we have end-to-end process communication, customer involvement, individualization. We have ecosystems, ubiquity. And what is the key area here is that data plays an important role in connecting all these different aspects and and providers, organizations involved in the provisioning of services. And we have data from value chains, which is usually private data, but we also have public data about transport networks, about public services, about weather, and much more, which also plays an important role and is very important to create really smart services. So this demonstrates a bit the need that we need a platform, a technology, we need standards to manage data across different organizations, not only within, and that's what the industrial data space is about. There is a number of principles this industrial data space is grounded on. One is to establish trust by certifying participants in the data space, by certifying the technology they are using to exchange data. It's a decentralized approach, so a distributed, decentralized architecture without a big data silo or a cloud infrastructure which everyone has to use. This results in more sovereignty over data and services, so you can decide whether you want to share data, with whom you want to share the data, under what conditions, under what licenses you want to share data. Also, there are data governance rules of the game which should be established in this club of participants in a data space, a network of different platforms and services, of course economies of scale, that we have network effects. The more participants share data in such a data space, the more attractive, the more interesting it is, and the more innovative new services can be developed. And of course the whole architecture should be open, neutral, and user-driven. We also want to support vertical cooperation between different usage areas. Generally, the industrial data space is generic, without one particular application area in mind. Why is that? Because we also think the interesting applications are between different application areas, that you use data in unforeseen ways and use it in different domains. And some examples where we are currently working on is material sciences, energy business, life sciences, supply chains, of course, and traffic management. So the industrial data space, on the one hand, fills a bit a gap between transmission networks, internet, real-time systems, and smart services. And it also crosses different areas, different domains. So can be applied, for example, in finance and retail. One particular focus is Industry 4.0, or how it's called in France, Industrie du Futur, or in the US, Industrial Internet. I guess you have other names for that. Basically, the combination of IT and manufacturing, automatization in manufacturing. So how does the architecture and the functionality of this data space look like? And that's depicted on this slide. The general idea is that companies have a data connector. That's what you see here in the center of the... Oh, sorry, the pointer doesn't work. So an external connector which allows to publish data and to consume data. In order to make it very secure, and that's one particular aspect of the data space, it should be secure and a safe environment for sharing data. This external connector is decoupled from an internal connector. The internal connector can communicate with internal systems like ERP systems, manufacturing execution systems, sensor networks in the production environment. And certain data assets are uploaded or pushed to this external connector. The external connector makes this data assets then available to specific partners, and these partners can then use the data sets and the data assets for providing services or for collaborating with the company. It's also possible to outsource this function of running an external data connector, IDS connector. So that's what you see here, that there might be a cloud provider running this external connector for a smaller company which would like to outsource this effort. There are two more components. One is a broker, which is an optional component. Broker is someone who has an overview of what connectors are available, what data they have, what data formats, data assets are available in such a data space. And of course, something like an app store, which allows to transform data between those different back-end formats, representations into the formalisms of the IDS connector, which also contains vocabularies which describe the semantics of the data. And I would like to tell you a bit more about this in a minute. There are four basic roles. Two are mandatory, the other two are optional. So a data owner provides data, data user is using data. Of course, you can also participate in several roles in the data space. There is also the broker and certification authority, which certifies that certain security standards, for example, are enforced and that the data connector adheres to the standards which are defined in the industrial data space. I was already mentioning broker and app store provider, which are additional roles also here. And of course, each role can be fulfilled by several participants. So there's also not only one broker, there might be also different app stores, different certification authorities. Maybe there will be even different data spaces for different purposes with different governance structures. But we are still also in a bit early stage here. One crucial aspect in addition to the security is describing the semantics of the data, because if I want to exchange data between different organizations, I have to have a common understanding. Otherwise, it will be a big mess. We want to build on W3C standards, which were developed in the last 15 years, which provide standards for semantic knowledge representation. So providing raw data, ground truth, as RDF, as well as metadata, and also the structure, the vocabularies. So we want to use these RDF standards. I guess many of you have seen this semantic web layer cake, which was done 15 years ago in 2001. I created a newer version of that, which shows that RDF meanwhile became more a lingua franca of data integration. So we have not only, as it previously used to be, a binding to XML, to an XML layer, but meanwhile we have bindings to many different technology ecosystems. In addition to XML, we can map JSON data and transform JSON data with JSON LD to RDF. We can map relational tabular data, CSV, to RDF, relational data with the RAML standard. We can embed RDF in HTML with RDFA, which, by the way, is already available in 20% of the websites. So that makes RDF, in a way, a perfect candidate for representing data, raw data, as well as metadata, and the structure and vocabularies, which you see here on these higher levels for describing the structure of the data. For one important aspect is we need to develop these kind of vocabularies which capture the domain-specific semantics. Of course, there are a lot of standards or models already. For example, in the supply chain domain, we have the SCORE supply chain reference model. In the mobility area, we have the DATEX2 standard, and so on and so forth. So there are many domain models, but they are very conceptual. Often they are just large documents which you can read, which describe the terms and the concept in that area. So we want to make this more operational, executable by developing such a vocabulary, which then can be also executed and mapped and used to transform and integrate data between operational systems. And for that, we developed an environment called Vocal, which uses Git as a version control system to collaboratively develop these semantic models, these vocabularies. Because I think it's also very important that digitization is not something you can introduce and then you are digital, but you need permanently to adapt the semantic models. You need to refine, extend it, expand it. So it's it's more a process than something you can achieve in just one run. And in order to support that, in particular for scenarios like Industry 4.0, so what you see here is what the platform Industry 4.0 in Germany developed is, on the one hand, a reference architecture called RAMI, Reference Architecture for Industry 4.0, and administrative shell, which is like the concept of equipping devices in the manufacturing area with a digital identity and with interface to all information. And in order to make these conceptual ideas and models operational, we developed vocabularies for supporting that and the environment for maintaining, for expanding and further developing these vocabularies. And I want to show you some screenshots. So this is your vocabulary development environment where you see a vocabulary for Industry 4.0 about plants, buildings. You see here workshops, gates, office location sites, enterprises. And once you look into the documentation, you can see all the classes which are defined in this vocabulary. We can look at one particular class here, machine. So this looks very similar. Some of you might have seen schema.org. If you look at the schema.org vocabulary, which is defined by Google, Yandex, Microsoft, and Yahoo. Similarly, Vocal supports the documentation of concepts, and you see here all the attributes. This is, for example, machine, all the attributes a machine can have and the expected types which are expected when you use this kind of attribute. You can visualize that with Vowel, which is a tool developed by my colleague Steffen Lohmann, which shows you a visual representation of the vocabulary, the concepts, the terms, and the relationships. You can also execute queries, so you get out of the box a Sparkle endpoint. You can run certain queries and you can test your vocabulary. Does it really answer certain questions? And you can visualize them in different ways on a map, for example, as well. You can write your own Sparkle queries. This is a bit similar maybe to test-driven software development, where you write test cases first. Similar in the vocabulary, you can write queries to test your vocabulary. And this is, I think, a very important aspect to bridge between this conceptual level, where we model, where we describe terms on a conceptual level, and the operational level, where we have concrete IT systems, where we want to integrate data, exchange data, publish data. You can also track the evolution. Since we use Git as a basis for version control, we have a log of all the commits of all the changes of the vocabulary, and you can then see what has happened, who has added what, and you can also implement fine-grained governance structures to define who can apply changes to a certain branch of the vocabulary, who is allowed to release a branch as a released version, and so on. In the industrial data space, there are now a number of enterprises, companies supporting the data space. It's a member association that was kicked off by Fraunhofer, but meanwhile it becomes an independent entity. So here you see some of the members of the industrial data space which exchange experience, which develop together new business models, which provide input for the standardization certification, implement use cases and projects, pool requirements and use cases, and you're very much invited to join this. It's an open association, so everyone can apply for membership and become a member in the association. There are different use cases, working groups. It's a platform for exchanging information. Of course, we implement this architecture, which I've shown you currently as a reference implementation. We also plan to release a large part of it as open source later on, but everybody is also invited. Software companies can create their own versions of an industrial data space connector if it adheres to the standards, and provide compatibility basically to the industrial data space. And as a last, so you can visit us. We have a stand on the second round where you can get more information about industrial data space. And I would like to mention one additional project which has a bit a different angle, which is tackling also the variety aspect. If we look at big data is something very important in companies. commonly there is a lot of focus on velocity and data volume, but we have not so much support yet for variety. And that's what we work on in the project Big Data Europe, which develops an approach for semantifying data lakes so that you have a semantic description of the data. Once you have this, you can also then more easily exchange it in the industrial data space. This is a different project which I also wanted to mention, which tackles a bit more the internal analytical maybe functions inside an organization to exploit big data components, technologies. We have developed a big data platform based on standard components and distributions for big data components. And there is also a stand you can visit for Big Data Europe on the 4th level. Yeah, thank you very much for your attention, and I hope we have time for 1 or 2 questions.